During the Apollo missions, astronauts traveling behind the far side of the moon reported something they never expected to hear in the silence of space. As their spacecraft slipped out of contact with Earth, a strange sound began to fill their headsets. It wasn't static. It wasn't a mechanical malfunction. The astronauts described it as eerie, almost like music. For several minutes, the sound echoed through their radios while they floated above the hidden side of the moon. When the spacecraft emerged from behind the lunar horizon, the sound vanished just as suddenly as it had appeared. That wasn't the only strange thing astronauts noticed during the Apollo missions. Some reported seeing unexplained lights moving across the lunar surface far below them. Others described the moon as strangely unsettling while orbiting above its gray landscape. Decades later, recordings from the missions revealed odd bursts of radio interference and conversations between astronauts trying to understand what they were hearing. But these mysteries didn't begin with Apollo. For centuries, astronomers staring through telescopes have occasionally reported flashes of light appearing on the moon. Sometimes, glowing patches seemed to shimmer briefly across the surface. At other times, observers described hazy clouds or strange shadows that appeared and then vanished without explanation. These events became known as lunar transient phenomena, and even modern scientists have struggled to determine what causes them. At the same time, the moon itself is one of the strangest objects in the entire solar system. It is far larger than most moons compared to the planet it orbits. Its size creates a remarkable coincidence in our sky, where the moon and sun appear almost exactly the same size during solar eclipses. The moon also keeps one face permanently turned toward Earth, hiding its far side from human view. And when scientists studied vibrations from impacts during the Apollo missions, they discovered something even more unusual. The moon seemed to resonate for far longer than expected, almost as if it were ringing like a bell. Taken individually, each of these mysteries might seem like an isolated curiosity, but together, they paint a far stranger picture of the moon than most people realize. Why did astronauts hear unexplained sounds while orbiting the far side of the moon? What causes the strange flashes and lights that observers have reported for centuries? Why does the moon behave so differently from other moons in the solar system? And after decades of exploration, how is it possible that so many basic questions about our nearest cosmic neighbor still remain unanswered? Tonight, we're going to explore the strangest mysteries of the moon and the discoveries that suggest our closest neighbor may be far more unusual than we ever imagined. In July of 1969, humanity reached the moon for the first time. Millions watched as Apollo 11 descended toward the Sea of Tranquility. The world remembers Neil Armstrong's first words and the moment his boot touched lunar dust. Yet behind the historic images was an environment that astronauts often described as deeply unsettling. The moon looked nothing like Earth. The sky remained perfectly black even in full daylight. Shadows were razor-sharp and seemed unnaturally dark. The horizon appeared much closer than expected because the moon is smaller than Earth. Many astronauts later said the landscape felt strangely artificial, almost like standing inside a silent desert frozen in time. It was beautiful, but also profoundly alien. Buzz Aldrin later explained that the moon's stillness felt almost eerie. There was no wind, no movement, and no sound beyond the astronauts' breathing. The lunar surface had been unchanged for millions of years. Footprints could remain visible for centuries. Even the dust behaved differently than anything found on Earth. Lunar soil is extremely fine, but also jagged under a microscope because it was never worn smooth by water. As astronauts walked, the dust rose slowly and fell straight back to the ground. The silence of the moon was absolute. Without air, sound cannot travel. The only noises astronauts heard came through their radios and life support systems. Many astronauts later described this isolation as psychologically intense. Michael Collins, who orbited the moon alone while Armstrong and Aldrin explored the surface, once explained that he was the most isolated human in history during that moment. As his spacecraft passed behind the moon, Earth disappeared completely from view. For nearly an hour, Collins had no communication with anyone. Mission Control could not hear him. His crewmates on the surface could not hear him. For those brief periods, he was entirely alone in deep space. That strange isolation became even more mysterious during an earlier mission. In May of 1969, 2 months before the first moon landing, Apollo 10 traveled to the moon for a full dress rehearsal of the landing procedure. The astronauts flew the lunar module down to within about 15 kilometers of the surface. Their spacecraft then passed behind the moon's far side, where radio contact with Earth disappeared. During this quiet period, astronauts Thomas Stafford and Eugene Cernan began hearing a strange sound in their headsets. It was a faint whistling tone that slowly rose and fell in pitch. The noise lasted several minutes. Inside the spacecraft, the astronauts quietly discussed what they were hearing. At one point, one of them compared the sound to strange outer space music. Because they were temporarily cut off from mission control, the crew debated whether to mention the noise once communication returned. They eventually decided not to raise concerns unless it happened again. The sound faded away as their spacecraft moved back into contact with Earth. For decades, this moment remained buried inside Apollo mission transcripts. In 2008, NASA released archived recordings that included the conversation. When people heard the astronauts describing mysterious music on the far side of the moon, the story quickly spread online. Some interpreted it as evidence of something unknown near the moon. NASA engineers later explained that the sound was most likely caused by interference between 2 VHF radios operating simultaneously inside the spacecraft. Even so, the moment remained fascinating because the astronauts themselves had no explanation at the time. The Apollo missions produced other unusual observations as well. During the journey to the moon on Apollo 11, Buzz Aldrin noticed a bright object outside the spacecraft window. The object appeared to move alongside the command module for several minutes. Aldrin asked Mission Control whether any parts of the Saturn V rocket were still nearby. Engineers suggested it could be a panel from the spacecraft's adapter section that had separated earlier during the mission. That explanation seemed reasonable. Yet Aldrin later said the object's motion appeared unusual through the telescope window. Because astronauts were cautious about public interpretation, they avoided speculating about what it might be. Other Apollo crews reported strange flashes of light while orbiting the moon. Some astronauts described brief bursts that appeared outside their spacecraft windows. Scientists later suggested that these flashes were likely caused by cosmic rays striking the astronauts' retinas. High-energy particles from deep space can interact with the human eye in microgravity. When this happens, astronauts may see sudden streaks or sparks of light, even in complete darkness. These events were later studied during Apollo missions as part of human spaceflight research. Yet not every observation had an immediate explanation. Several Apollo astronauts mentioned seeing distant glows or reflections on the lunar surface. These observations were often subtle and difficult to verify. Sometimes the lights appeared near the horizon while the spacecraft was in orbit. In most cases, scientists believe these were sunlight reflections from lunar terrain or small meteoroid impacts. Tiny rocks frequently strike the moon because it lacks a protective atmosphere. When these impacts occur, they can briefly produce flashes visible from orbit. The Apollo missions also experienced unusual radio disturbances at times. Space communication during the 1960s relied on complex networks of antennas and relay satellites. Signals could sometimes distort when spacecraft orientation changed or when the moon's surface interfered with radio waves. Engineers carefully studied these anomalies throughout the Apollo program. While most were eventually understood, they contributed to the sense that space was an unpredictable environment. One of the most important communication challenges occurred whenever spacecraft moved behind the Moon. During these periods, astronauts entered what engineers called LOS, or loss of signal. The Moon itself blocked radio transmissions from reaching Earth. For roughly 45 minutes each orbit, astronauts were completely cut off from mission control. No one on Earth could hear them, and they could not receive instructions. Engineers could only wait for the spacecraft to reappear. These silent periods created tension for mission controllers in Houston. If a serious problem occurred while the spacecraft was behind the Moon, help would be impossible. The crew would have to solve the problem alone. Apollo flight controllers often watched their telemetry screens carefully as spacecraft approached the far side. Once the signal vanished, they waited anxiously for the moment communication returned. Decades later, historians began exploring the vast archives of Apollo recordings. NASA had preserved thousands of hours of mission audio, including private communication loops between astronauts and engineers. When many of these recordings were digitized in the early 2000s, researchers discovered small moments of curiosity scattered throughout the missions. Astronauts sometimes mentioned unusual sights or unexpected technical behavior. Most of these moments were minor and quickly explained. However, they revealed how unfamiliar space exploration still was during the Apollo era. These discoveries also fueled public fascination with the Moon. Over the years, various conspiracy theories began circulating online. Some claimed astronauts encountered unknown structures on the lunar surface. Others suggested NASA hid evidence of extraterrestrial activity near the Moon. None of these claims are supported by credible evidence. Scientists emphasized that the Apollo missions were among the most carefully documented events in history. Every spacecraft maneuver, radio transmission, and experiment was recorded in extraordinary detail. Yet the existence of these conspiracy theories highlights something important about human curiosity. The Apollo astronauts were the first humans to experience the Moon directly. They walked across landscapes no person had ever seen up close. Even small mysteries can become powerful stories when they occur in such a remote and unfamiliar place. The Moon itself also contributes to this sense of wonder. From Earth, it appears calm and unchanging. But up close, the lunar surface tells a story of violent impacts and ancient geological forces. Craters stretch across thousands of kilometers. Lava plains fill massive basins formed by asteroid collisions billions of years ago. The Moon preserves this history because it lacks weather and erosion. For astronauts standing there, the experience could feel surreal. The ground beneath their boots was older than almost any rock on Earth. The sky above them remained permanently black, and hanging in that sky was the Earth itself, glowing blue and white above the lunar horizon. Despite the strange environment, the Apollo missions achieved extraordinary scientific success. Astronauts collected hundreds of kilograms of lunar rocks. They installed instruments that measured moonquakes and the Moon's internal structure. Reflectors placed on the surface still allow scientists to measure the Moon's distance with lasers today. These experiments transformed our understanding of Earth's closest celestial neighbor. Yet even with all of that knowledge, the Apollo missions also revealed how much we still do not understand about the Moon. Strange sounds in spacecraft radios, mysterious flashes in the darkness of space, and the profound silence of the lunar landscape all left lasting impressions on the astronauts who experienced them. And perhaps the most intriguing mystery of all did not come from astronauts in orbit. It came from astronomers on Earth who had been watching the Moon long before the Apollo era began. For centuries, observers looking through telescopes reported brief flashes and glowing patches on the lunar surface. Some of these lights appeared suddenly and faded within minutes. Others lingered for hours before disappearing again. Scientists eventually gave these events a name: lunar transient phenomena. No astronauts had yet witnessed these strange lunar lights directly, but their existence suggested something important. Even after humans finally reached the moon, it might still hold mysteries waiting to be understood. And those mysteries begin not with astronauts, but with the strange flashes that observers had been seeing on the moon for hundreds of years. Long before astronauts orbited the moon, astronomers were already witnessing strange and fleeting changes across its surface. These observations began centuries before the space age, when early telescopes first allowed scientists to study the moon in detail. In 1787, the renowned British astronomer William Herschel reported something unusual while examining the lunar surface. Through his telescope, Herschel noticed several glowing spots that appeared to resemble active volcanic eruptions. The bright patches seemed to flicker and glow in a way that reminded him of molten lava. At the time, many scientists believed the moon might still contain active volcanoes. Herschel carefully documented the observations and concluded that he might be witnessing volcanic activity unfolding in real time. Later research showed that the moon's volcanoes had been inactive for billions of years, yet Herschel's report became one of the earliest records of strange temporary changes on the moon. During the 19th century, reports like Herschel's began appearing more frequently across Europe. Astronomers using improved telescopes occasionally described flashes of light or glowing patches appearing on the lunar surface. Some observers claimed to see small clouds or hazy plumes rising above certain craters. Others reported brief bursts of brightness that faded within seconds. Because these events were unpredictable and short-lived, scientists struggled to confirm them through repeated observation. Most telescopes at the time were pointed at the moon only periodically, and many events disappeared before other astronomers could verify them. Despite this uncertainty, the reports continued to accumulate. Gradually, astronomers began suspecting that something subtle but real might occasionally occur on the moon's surface. By the early 20th century, scientists began organizing these unusual observations into a specific category. They called the phenomenon lunar transient phenomena, often abbreviated as LTP. The term refers to temporary changes in brightness, color, or appearance observed on the moon. These changes may include flashes of light, glowing patches, darkening regions, or brief clouds that appear and vanish. Because the moon lacks weather, clouds, and a thick atmosphere, any temporary visual change immediately attracts attention. Astronomers began compiling detailed catalogs of these events in an attempt to identify patterns. By the 1960s, more than 1,500 reports of possible LTP had been recorded by observers around the world. One of the most famous observations occurred in 1958 and involved the Soviet astronomer Nikolai Kozyrev. While studying the crater Alphonsus with a large telescope, Kozyrev noticed a reddish glow forming inside the crater floor. Unlike earlier visual reports, Kozyrev attempted to analyze the light using spectroscopic instruments. Spectroscopy allows scientists to identify the chemical composition of gases by examining the wavelengths of light they emit. Kozyrev reported detecting signals that appeared consistent with carbon-based gases rising from the crater. If correct, this would suggest that small amounts of gas might occasionally escape from beneath the moon's surface. The observation was controversial and difficult to repeat, but it sparked renewed interest in the possibility that the moon might not be entirely inactive. Only a few years later, another dramatic observation drew international attention. In 1963, astronomer James A. Greenacre was observing the moon from the Lowell Observatory when he noticed bright flashes near the crater Aristarchus. Aristarchus is one of the brightest and most reflective features on the moon's surface. Because of its brightness, even small changes in illumination can be easily noticed. Greenacre described the flashes as small glowing points that seem to appear and disappear rapidly. Other astronomers observing the moon at the same time confirmed seeing similar flashes in the same region. The event quickly became one of the best documented examples of lunar transient phenomena. The region around Aristarchus has remained particularly interesting to scientists. The surrounding terrain contains fractures, ancient lava channels, and evidence of past volcanic activity. Some researchers believe that small amounts of gas may occasionally escape through cracks in the lunar crust. When gas rises from beneath the surface, it may disturb fine lunar dust and create brief luminous effects. Sunlight, reflecting from these particles, could produce the flashes observed by astronomers. Although direct evidence remains limited, the Aristarchus region has produced an unusually high number of LTP reports over the decades. Astronomers have also occasionally reported seeing faint haze or mist-like clouds above certain lunar craters. These hazy formations appear as subtle blurring or soft glowing patches on the surface. They usually disappear within minutes. Because the moon has almost no atmosphere, the presence of haze is surprising. One possible explanation involves gas slowly leaking from underground pockets within the lunar crust. If gas escapes through small cracks, it may lift fine dust particles into the weak lunar gravity. The dust could remain suspended for a short time before settling back onto the surface. When sunlight strikes these floating particles, they might appear as faint mist or glowing clouds. Another explanation for some LTP events involves meteor impacts. Unlike Earth, the moon has no atmosphere to burn up incoming space debris. Meteoroids traveling through space can strike the lunar surface at speeds exceeding 20 kilometers per second. When such impacts occur, the energy released can produce extremely bright flashes of light. In recent decades, astronomers have begun detecting these flashes using high-speed cameras and sensitive telescopes. One particularly large impact flash occurred on March 17, 2013, when a meteoroid struck the moon and produced a brief but powerful burst of light visible from Earth. The flash lasted less than a second, but released energy equivalent to several tons of TNT. While meteor impacts explain some observations, they cannot account for every report in the historical record. Another process may involve electrostatic dust movement across the lunar surface. The moon is constantly bombarded by charged particles carried by the solar wind. These particles can accumulate electrical charge on the surface of fine lunar dust grains. Under certain conditions, the dust becomes electrically repelled from the ground and begins to float slightly above the surface. This process is most likely to occur during lunar sunrise and sunset, when the boundary between sunlight and darkness moves across the landscape. Dust grains lifted by electrostatic forces can scatter sunlight and produce glowing horizon effects. Evidence for this phenomenon emerged during the Apollo era itself. Astronauts orbiting the moon occasionally described seeing faint glowing bands near the lunar horizon during sunrise. These observations were later analyzed by scientists studying lunar dust behavior. Instruments placed on the moon during the Apollo missions detected subtle electric fields forming above the surface. These electric fields may play a role in lifting dust particles and creating temporary glowing effects. Although these events are subtle and difficult to observe from Earth, they may contribute to some reports of lunar transient phenomena. Before the Apollo landings, NASA scientists took LTP reports seriously enough to influence mission planning. Researchers reviewed decades of telescope observations to identify regions where unusual activity had been reported frequently. Some of these locations were considered particularly interesting targets for scientific exploration. The idea was simple. If temporary changes were occurring on the moon, astronauts might be able to investigate the areas directly. Although the Apollo missions did not confirm any dramatic activity, the possibility of subtle geological processes remained a topic of scientific interest. Even today, lunar transient phenomena remain difficult to study. Most events occur unexpectedly and last only a few seconds or minutes. By the time telescopes are pointed toward the correct region, the phenomenon may already have vanished. Modern lunar orbiters equipped with cameras and spectrometers have improved our ability to monitor the moon's surface. However, capturing a transient event in real time remains challenging. Scientists suspect that many LTP reports may be caused by natural processes such as meteoroid impacts, gas releases, or dust movements. Yet each observation raises new questions about how active the moon truly is beneath its quiet exterior. Human perception may also play a role in some reports. Observing the moon through Earth's atmosphere can create visual distortions caused by turbulence in the air. These distortions sometimes cause brief flashes or color changes in bright lunar features. In other cases, the human brain may interpret random patterns of light and shadow as unusual activity. Astronomers therefore approach LTP reports cautiously and require multiple independent observations before drawing conclusions. Even so, the sheer number of historical reports suggests that at least some lunar transient phenomena may reflect real physical events occurring on the moon. These mysterious flashes and glows reveal something important about our nearest celestial neighbor. For centuries, the moon was believed to be a completely dead world, frozen in time and unchanged for billions of years. Yet observations of lunar transient phenomena suggest that subtle processes may still occur beneath its surface. Small gas releases, electrostatic dust movements, and meteoroid impacts may occasionally disturb the lunar landscape. These events are rare and fleeting, but they remind scientists that the moon is not entirely static. The stories from astronomers and astronauts now begin to intersect. The unexplained lights seen through telescopes echo the strange flashes and distant glows occasionally reported by Apollo crews. Together, these observations hint that the moon may still possess hidden processes that science is only beginning to understand. But an even deeper mystery soon emerges when scientists step back and examine the moon itself. Because when astronomers compare the moon to other moons across the solar system, something remarkable becomes clear. Our moon may be one of the strangest celestial objects ever discovered. When scientists compare the moon to other moons in the solar system, something unusual becomes immediately clear. Most moons are tiny compared to the planets they orbit. Earth's moon, however, does not follow this pattern. In fact, it is one of the largest moons relative to its parent planet anywhere in the solar system. With a diameter of about 3,474 kilometers, the moon is more than 1/4 the diameter of Earth. This may not seem extraordinary at first glance, but when astronomers compare it with other planetary systems, the difference becomes striking. Our moon is unusually large for a rocky planet. To understand why this matters, scientists often look at other moons in the solar system. Many planets possess dozens of moons, yet most are extremely small. The gas giant Jupiter, for example, has more than 90 known moons. Even its largest moons are relatively small compared to the enormous planet they orbit. The same pattern appears around Saturn and Uranus. These planets are surrounded by swarms of small moons formed from disks of gas and debris that once circled the young planets. In these systems, no single moon dominates the orbital environment the way Earth's moon does. Earth's situation is completely different. Instead of many small moons, Earth has one large companion. The moon contains about 1% of Earth's mass, which is unusually high for a satellite. Because of this relationship, some astronomers have suggested that the Earth-Moon system resembles a kind of double planet. In this configuration, both bodies influence each other gravitationally in significant ways. The center of gravity of the Earth-Moon system, known as the barycenter, lies inside Earth but not at its exact center. Both Earth and the Moon orbit around this shared point in space as they travel around the Sun. This unusual size relationship puzzled astronomers for centuries. Early scientists who studied planetary motion expected moons to be much smaller than their parent planets. That expectation was based on observations throughout the solar system. Yet the moon did not fit neatly into that pattern. As telescopes improved during the 17th and 18th centuries, astronomers began measuring planetary sizes more accurately. When they compared the dimensions of Earth and the Moon, they realized that the Moon was unusually large compared with its host planet. This discovery raised an important question. Why would Earth possess such an unusually large moon when the other rocky planets do not? When scientists examined the inner solar system, they found that the pattern continued. Mercury and Venus have no moons at all. Mars has 2 moons, but they are tiny and irregularly shaped. These moons, called Phobos and Deimos, appear to be captured asteroid fragments rather than large natural satellites. Only Earth possesses a moon large enough to dominate the night sky and strongly influence the planet's environment. The moon's unusual characteristics do not stop with its size. Its orbit around Earth is also remarkably stable. The moon travels around Earth at an average distance of about 384,400 kilometers. While the orbit is slightly elliptical, its overall path remains consistent over long periods of time. This stability is important because the moon's gravity plays a significant role in shaping Earth's tides and rotational behavior. As the moon orbits Earth, its gravitational pull stretches the oceans slightly, producing the familiar rise and fall of ocean tides. Scientists now understand that this interaction also affects Earth's long-term stability. The moon helps stabilize the tilt of Earth's rotational axis, known as axial tilt or obliquity. Earth's axis is tilted about 23.5 degrees relative to its orbit around the Sun. This tilt produces the seasons we experience each year. Without the moon's gravitational influence, Earth's tilt might vary much more dramatically over time. Computer simulations suggest that a moonless Earth could experience chaotic swings in axial tilt. These changes might drastically alter global climates over millions of years. The moon's presence, therefore, contributes to the long-term stability of Earth's climate system. This fact was not fully appreciated until the late 20th century. Planetary scientists studying other worlds realized that many planets experience dramatic shifts in axial tilt over time. Mars, for example, has undergone large changes in tilt throughout its history. These shifts may have produced major climate variations across the planet. Earth's relatively stable tilt may be partly due to the steady gravitational influence of the moon. Another remarkable feature of the moon involves one of the most spectacular events visible from Earth. Occasionally, the moon passes directly between Earth and the Sun. When this alignment occurs, the moon can block the Sun completely, producing a total solar eclipse. During these rare moments, the sky darkens and the Sun's outer atmosphere becomes visible as a glowing halo. The reason this occurs is an extraordinary cosmic coincidence. The moon is roughly 400 times smaller than the Sun in diameter, yet it also happens to be about 400 times closer to Earth than the Sun is. Because of this precise ratio, the moon and Sun appear almost exactly the same size in Earth's sky. When the moon moves directly in front of the Sun, the two disks align almost perfectly. This alignment allows the moon to cover the Sun's bright surface while leaving the faint solar corona visible around the edges. The result is one of the most dramatic astronomical sights humans can witness. Total solar eclipses have fascinated observers for thousands of years. Ancient civilizations often interpreted them as powerful omens or supernatural events. However, this remarkable alignment is not permanent. The moon is slowly moving away from Earth over time. Measurements made using laser reflectors left on the moon during the Apollo missions show that the distance between Earth and the moon increases by about 3.8 centimeters each year. This may seem like an insignificant amount, but over millions of years, the change becomes substantial. Hundreds of millions of years ago, the moon appeared significantly larger in Earth's sky. During that era, solar eclipses would have looked different from those we see today. The moon would have covered the Sun more easily and more frequently. In the distant future, the opposite will occur. As the moon continues to drift away, it will gradually appear smaller in the sky. Eventually, it will no longer be large enough to completely block the Sun. When that time arrives, total solar eclipses will disappear from Earth entirely. Instead of perfectly covering the sun, the moon will leave a bright ring of sunlight visible around its edges. Astronomers call this an annular eclipse. Scientists estimate that the era of perfect total eclipses will eventually come to an end hundreds of millions of years from now. This realization highlights another unusual aspect of the Earth-Moon system. The alignment that allows total solar eclipses exists only during a relatively narrow window of Earth's history. For a brief period on a cosmic timescale, the sizes and distances of the Sun and Moon align almost perfectly from Earth's perspective. Before this era, the Moon appeared larger than the Sun. After this era, it will appear smaller. While these coincidences are fascinating, they also raise deeper questions for scientists studying the Moon's origin. For centuries, astronomers struggled to explain how such an unusual satellite could have formed. Several competing theories were proposed. One early idea suggested that the Moon formed alongside Earth from the same cloud of material that created the solar system. According to this co-formation theory, both bodies would have condensed from the same swirling disk of gas and dust around the young Sun. While this idea seemed plausible at first, it failed to explain several important details about the Moon's composition. Another theory suggested that the Moon formed elsewhere in the solar system and was later captured by Earth's gravity. This capture theory attempted to explain the Moon's size by proposing that it originated as an independent object. However, capturing such a large body would require a mechanism capable of slowing it down without destroying it. In most simulations, a captured object either escapes again or collides catastrophically with the planet. A third theory proposed that the Moon might have once been part of Earth itself. In this scenario, the early Earth was spinning so rapidly that a portion of its outer material separated and formed the Moon. While this fission theory attempted to explain similarities between Earth and lunar rocks, it required Earth to rotate at an unrealistic speed. Later research showed that such a scenario was extremely unlikely. For decades, none of these ideas fully solved the puzzle. The situation changed dramatically during the Apollo era. Between 1969 and 1972, astronauts from the NASA returned hundreds of kilograms of lunar rocks and soil to Earth. In total, the Apollo missions collected about 382 kilograms of lunar material from multiple locations across the Moon's surface. For the first time, scientists could study the Moon's composition directly in laboratories. The results were surprising. Many lunar rocks closely resembled the composition of Earth's mantle, the layer beneath Earth's crust. The rocks contained similar ratios of oxygen isotopes, suggesting that Earth and the Moon shared a common origin. Yet lunar rocks also showed important differences. The Moon contained far less iron than scientists expected for a planetary body its size. These discoveries forced scientists to reconsider the Moon's origin entirely. If the Moon formed from the same material as Earth, why was its internal structure so different? And how could such a large object form so close to our planet? The answer, scientists eventually realized, might involve one of the most violent events in Earth's history. Billions of years ago, something enormous may have collided with the young Earth. The impact would have been so powerful that vast amounts of molten rock were blasted into space. Over time, this debris may have gathered together and cooled, forming the Moon itself. This dramatic idea became known as the giant impact theory. It suggested that the Moon was born not from gentle processes, but from a colossal cosmic collision. And understanding that event would reveal one of the most extraordinary chapters in the story of our solar system. To understand how the Moon formed, scientists must travel far back into the earliest history of the solar system. More than 4.5 billion years ago, the Sun had only recently ignited. Around it spun a vast disk of dust, ice, and rock known as the solar nebula. Within this chaotic environment, small grains of matter began sticking together through electrostatic forces. Over time, those grains grew into larger objects called planetesimals. These bodies continued colliding and merging, gradually forming the first planetary embryos. The young solar system was not calm or orderly. It was violent, crowded, and constantly reshaped by massive impacts. During this era, Earth itself was still forming. Instead of the stable world we know today, the early Earth was a growing sphere of molten rock and metal. Asteroids and protoplanets frequently collided with it, adding new material and energy. Each impact released enormous heat that helped keep the young planet partially molten. Scientists believe that dozens of large collisions occurred during Earth's early development. Most of these events are lost to time. However, one particular collision may have changed the planet forever. According to modern planetary science, a Mars-sized protoplanet called Theia may once have shared a similar orbit around the Sun. The name Theia comes from Greek mythology. In ancient myths, Theia was the mother of Selene, the goddess associated with the moon. Astronomers use the name as a symbolic reference to the body that may have given birth to our lunar companion. This hypothetical world likely formed in the same region of the solar system as Earth. Over millions of years, gravitational interactions gradually altered its orbit. Eventually, Theia's path may have drifted dangerously close to Earth. At that time, both bodies were still molten and partially differentiated. Their interiors had begun separating into layers of metal cores and rocky mantles. When their orbits finally intersected, the result would have been one of the most powerful collisions in planetary history. Scientists estimate that the impact occurred about 4.51 billion years ago, when the solar system was still extremely young. The collision itself would have been unimaginably violent. Computer simulations suggest that Theia struck Earth at an oblique angle rather than directly head-on. This glancing impact may have occurred at speeds exceeding 10 kilometers per second. The energy released would have been equivalent to billions of nuclear explosions. Instead of simply shattering the two bodies, the collision likely vaporized enormous quantities of rock and metal. A large portion of Earth's outer layers and Theia's mantle were blasted into space. Despite the immense energy involved, Earth itself survived the collision. The planet's gravity retained most of its mass, though its surface was transformed into a global ocean of molten rock. Meanwhile, vast amounts of debris were thrown into orbit around the planet. This debris consisted mostly of vaporized rock, molten droplets, and fragmented material from both worlds. The material formed a glowing disk surrounding the young Earth. For a time, our planet may have been encircled by a ring of incandescent debris stretching thousands of kilometers into space. Within this disk, gravity began its slow but powerful work. Small particles started colliding and sticking together. Over time, these fragments grew into larger clumps through a process known as accretion. As collisions continued, the fragments gradually merged into a single growing body. Planetary scientists believe this process may have occurred surprisingly quickly. Some models suggest that the Moon could have formed within a few hundred years after the original impact. At first, the newborn Moon would have looked very different from the familiar gray world we see today. The early Moon was likely covered in a deep ocean of molten rock known as a magma ocean. Over time, this molten surface began cooling and crystallizing. Lighter minerals floated upward to form the Moon's earliest crust, while denser materials sank toward its interior. This gradual cooling process helped shape the Moon's internal structure. Evidence supporting this dramatic origin comes largely from samples returned during the Apollo missions. Between 1969 and 1972, astronauts from the NASA collected hundreds of kilograms of lunar rocks and soil from different regions of the Moon. In total, the missions brought back approximately 382 kilograms of material. These samples allowed scientists to study the Moon's composition directly for the first time. Laboratory analysis revealed something surprising. Many lunar rocks closely resemble the composition of Earth's mantle, the rocky layer beneath Earth's crust. In particular, the ratios of certain elements and isotopes were remarkably similar between lunar material and terrestrial rocks. This similarity suggested that much of the Moon formed from material that originally belonged to Earth. If the giant impact theory was correct, the Moon may have formed largely from Earth's outer layers that were blasted into orbit during the collision. However, the Moon also shows important differences from Earth. One of the most significant involves its internal structure. Earth contains a massive iron core that accounts for roughly 1/3 of its total mass. The Moon, by contrast, possesses a much smaller iron core relative to its size. Scientists estimate that the lunar core represents only a small fraction of the Moon's total mass. This difference makes sense if the Moon formed mainly from Earth's mantle, which contains less iron than the planet's core. Researchers have spent decades refining computer simulations of the giant impact event. Institutions such as NASA and laboratories at universities around the world have developed increasingly sophisticated models. These simulations recreate the physics of planetary collisions in extraordinary detail. By adjusting variables such as impact speed, angle, and planetary rotation, scientists attempt to reproduce a Moon with the same mass, orbit, and composition observed today. Many of these models successfully produce a lunar system similar to the real one. Yet the theory still faces challenges. One of the most puzzling questions involves the remarkable chemical similarity between Earth and the Moon. If Theia contributed a significant portion of the material forming the Moon, scientists expected to find clear chemical differences between lunar rocks and Earth's mantle. Instead, the compositions appear almost identical in many respects. To explain this, some researchers propose that the collision was even more energetic than earlier models suggested. In these scenarios, the impact produced a vast cloud of vaporized rock that thoroughly mixed material from both bodies. Over time, this mixture condensed and formed the Moon. Such intense mixing could explain why lunar material closely resembles Earth's composition today. Other scientists have proposed alternative variations of the impact scenario. One hypothesis suggests that the early Earth may have been spinning extremely rapidly before the collision. In this case, the impact could have flung large quantities of Earth's mantle into orbit, where they later assembled into the Moon. Another idea proposes that the Moon formed through multiple smaller impacts over time rather than a single catastrophic event. Each impact would have added additional debris to an orbital disk surrounding Earth. Another important piece of evidence supporting the giant impact theory comes from isotopic analysis. Atoms of the same element can exist in slightly different forms, called isotopes. These isotopes have identical chemical behavior, but slightly different masses. By measuring the ratios of oxygen isotopes in lunar samples, scientists discovered that Earth and the Moon share nearly identical isotopic signatures. These signatures differ from those found in most meteorites elsewhere in the solar system. The close match strongly suggests that the Earth and Moon formed from the same reservoir of material. Modern space missions have continued improving our understanding of the Moon's origin. One particularly important mission was Grail, launched by NASA in 2011. The mission consisted of 2 spacecraft that orbited the Moon while measuring subtle variations in its gravitational field. By studying these variations, scientists created extremely detailed maps of the Moon's interior structure. These maps revealed new information about the thickness of the lunar crust and the distribution of mass within the Moon. The Grail mission also provided insights into how the Moon cooled and evolved after its formation. Scientists discovered evidence that the lunar crust may have been heavily fractured during its early history. Some of these fractures may have formed as the young Moon cooled and contracted after its molten beginning. Understanding these internal structures helps researchers test competing theories about the Moon's formation. Even with all this evidence, the Moon's birth remains an active area of scientific research. Scientists continue debating the exact details of the collision that produced it. questions remain about the precise size of Theia, the angle of the impact, and how the debris disk eventually condensed into a single body. Each new model adds another piece to the puzzle while revealing new complexities in the story. Yet perhaps the most surprising discovery came from the rocks themselves. When scientists carefully dated some of the lunar samples brought back by the Apollo missions, they noticed something unexpected. A few of these rocks appeared to contain minerals that formed extremely early in solar system history. In some cases, the ages seemed to approach the age of Earth itself. This observation raised a strange and intriguing possibility. Some lunar materials might be older than Earth. This puzzling discovery leads directly into the next chapter of our story, where scientists confront one of the most unusual geological mysteries in planetary science. When the Apollo astronauts returned to Earth with boxes of lunar rocks, scientists immediately understood that they were holding something extraordinary. For the first time in human history, material from another world could be studied directly in laboratories on Earth. Between 1969 and 1972, astronauts from 6 Apollo missions collected hundreds of samples from different regions across the Moon's surface. These samples included basalts formed from ancient lava flows, fragments of the lunar highlands, and fine grains of lunar soil known as regolith. In total, the Apollo missions brought back about 382 kilograms of material. Each rock represented a frozen piece of lunar history waiting to be decoded. The first challenge scientists faced was determining how old these rocks were. Knowing the ages of the samples would help researchers reconstruct the Moon's geological history. To accomplish this, scientists used a technique called radiometric dating. This method relies on the predictable decay of radioactive elements contained within minerals. Certain elements, such as uranium and potassium, slowly transform into other elements over time. By measuring the ratio between the original radioactive isotope and its decay products, scientists can calculate how long it has been since the mineral crystallized. Radiometric dating works especially well on igneous rocks that formed from molten material. When molten rock cools and solidifies, radioactive isotopes become locked into the crystal structure of minerals. From that moment onward, the radioactive decay process begins ticking like a clock. By measuring these tiny atomic changes, scientists can estimate the age of the rock with remarkable precision. This method has been used to determine the ages of rocks from Earth, meteorites, and now the Moon. When the first lunar samples were analyzed, the results surprised researchers. Many of the rocks turned out to be extraordinarily ancient. Basalts collected from the Lunar Maria were often more than 3 billion years old. However, samples from the bright highland regions were even older. Some of these rocks showed ages exceeding 4.4 billion years. In fact, several samples approached 4.5 billion years in age, placing them among the oldest known rocks in the entire solar system. At first glance, this result seemed astonishing. Earth itself is approximately 4.54 billion years old. Yet almost none of Earth's original crust from that time remains today. The reason lies in the dynamic nature of our planet. Earth's surface is constantly reshaped by plate tectonics, erosion, and volcanic activity. Over hundreds of millions of years, old rocks are buried, melted, or recycled deep within the mantle. As a result, the oldest intact rocks on Earth are typically around 4 billion years old, and even those are extremely rare. The Moon, however, tells a very different geological story. Unlike Earth, the Moon has no active plate tectonics and almost no atmosphere. There is no rain to erode its surface and no moving continents to recycle its crust. As a result, the lunar landscape preserves ancient geological features that have remained largely unchanged for billions of years. Impact craters formed early in lunar history still remain visible today. This lack of geological activity allows lunar rocks to act as a time capsule from the earliest period of the solar system. Because of this preservation, scientists expected lunar rocks to be very old. Yet some of the samples appeared almost too ancient. Certain minerals discovered in the lunar highlands seem to record formation ages very close to the birth of the solar system itself. These minerals included tiny zircon crystals embedded within larger rocks. Zircons are particularly valuable to geologists because they are extremely durable and can survive intense geological processes. They also incorporate trace amounts of uranium when they form, making them excellent candidates for radiometric dating. When researchers examined some lunar zircons under powerful microscopes, they discovered ages approaching 4.46 billion years. These ages suggested that the minerals formed extremely early in lunar history. Some crystals may have crystallized only tens of millions of years after the solar system itself formed. This discovery raised an intriguing question. If the Moon formed during a massive impact between Earth and another protoplanet, how could such ancient minerals survive the intense heat of that collision? According to the giant impact theory discussed in the previous chapter, the Moon formed from debris produced when a Mars-sized body collided with the young Earth. The collision would have generated enormous temperatures, likely vaporizing large amounts of rock and creating a disk of molten material around Earth. That material eventually cooled and assembled into the Moon. If the Moon formed in this way, scientists expected most minerals to have been melted and reset during the process. Their radiometric clocks should have started when the Moon solidified after the impact. Yet the ages of some zircon crystals seemed older than expected. These minerals appeared to preserve chemical signatures dating back to extremely early periods of planetary formation. This discrepancy created what some researchers call the Moon's age paradox. If the Moon formed from a giant collision that melted much of the material, why do some minerals appear to preserve such ancient ages? One possible explanation involves fragments of material that survived the impact. Although the collision would have been extremely energetic, some pieces of rock may have escaped complete melting. These fragments could have been incorporated into the debris disk that later formed the Moon. If these surviving pieces originated from either the early Earth or from the impact of Theia, they might retain isotopic signatures older than the Moon itself. Another explanation focuses on the cooling process of the Moon's early surface. Many scientists believe that shortly after its formation, the Moon was covered by a global magma ocean. This magma ocean may have been hundreds of kilometers deep and composed of molten rock created by the giant impact. As the magma ocean cooled, minerals began crystallizing and separating according to their density. Lighter minerals floated upward and eventually formed the Moon's first crust. Denser minerals sank deeper into the interior. During this process, zircons could have crystallized relatively early in the Moon's history, while the magma ocean was still cooling. These crystals might record the earliest stages of lunar crust formation rather than pre-existing material from before the impact. In this scenario, the ancient ages of the zircons do not necessarily mean they survived the collision intact. Instead, they may reflect how quickly the Moon cooled and began forming solid crust. Researchers at institutions such as NASA's Johnson Space Center and the University of Chicago have studied lunar zircons in extraordinary detail. Using high-resolution electron microscopes and sophisticated isotope analysis, scientists examined tiny variations in atomic structure within these minerals. These techniques allow researchers to reconstruct the thermal history of the Moon during its earliest stages. Even subtle changes in crystal structure can reveal how quickly the Moon cooled after its formation. Some scientists have proposed another intriguing possibility. If fragments of the impact of Theia were incorporated into the Moon, those fragments might preserve chemical signatures from another early planetary body. In that case, parts of the Moon could contain material that originally formed elsewhere in the young solar system. This possibility adds another layer of complexity to the Moon's origin story. Instead of being composed solely of Earth's material, The moon might contain a mixture of debris from two ancient worlds. Studying these ancient lunar rocks continues to refine our understanding of the early solar system. The moon's surface acts as a geological archive, preserving events that Earth itself has long erased. Every sample returned by the Apollo missions contains clues about the violent processes that shaped the planets. Impact craters, volcanic flows, and crystallized minerals all record different chapters in the moon's long history. Yet even after decades of study, many questions remain unresolved. Scientists still debate exactly how quickly the moon cooled after the giant impact. They also continue investigating whether some minerals truly preserve material older than the moon itself. Advances in analytical techniques allow researchers to measure isotopic variations at increasingly smaller scales. Each new measurement brings scientists closer to understanding the moon's earliest history. In some ways, the moon acts like a memory of the solar system's infancy. While Earth's surface has been constantly reshaped by tectonics and erosion, the moon preserves evidence of events that occurred billions of years ago. Its rocks record impacts from ancient asteroids, the cooling of magma oceans, and perhaps even fragments of other early planetary bodies. Yet the mysteries of the moon are not limited to its age. Another question has fascinated observers for centuries. Every night, people on Earth see the same familiar face of the moon shining overhead. The same craters, the same dark maria, and the same patterns appear again and again. But the moon has another side that remained hidden for most of human history. And as scientists eventually discovered, that hidden side looks very different from the one we see from Earth. For as long as humans have looked up at the night sky, the moon has appeared strangely familiar. The same dark plains, the same bright highlands, and the same crater patterns always face Earth. Night after night, century after century, the lunar landscape never seems to rotate into a new position. Ancient astronomers noticed this pattern thousands of years ago. Even without understanding the physics involved, they realized that the moon showed only one hemisphere toward Earth. The opposite side remained completely hidden from view. This phenomenon puzzled early observers. If the moon was a rotating sphere like Earth, why did its visible surface remain unchanged? The answer lies in a gravitational process known as tidal locking. Over long periods of time, gravity can synchronize the rotation of one celestial body with its orbit around another. In the case of the Earth-Moon system, Earth's gravity gradually slowed the moon's rotation billions of years ago. Eventually, the moon's spin slowed until it matched the time it takes to orbit Earth. Today, the moon completes one full rotation every 27.3 days. That is exactly the same amount of time required for one orbit around Earth. Because these two motions are synchronized, the same hemisphere of the moon always faces our planet. As the moon travels around Earth, it rotates just enough to keep that familiar face pointed toward us. The result is a cosmic balance that has remained stable for billions of years. Tidal locking occurs through a subtle but powerful process. When the moon formed, it likely rotated much faster than it does today. However, Earth's gravity created tidal forces within the moon's interior. These forces slightly distorted the moon's shape, stretching it into a subtle oval. As the moon rotated, the gravitational pull from Earth continuously tried to realign that bulge. Over time, this interaction produced friction inside the moon, gradually slowing its rotation. Eventually, the rotation slowed until the moon's bulge pointed permanently toward Earth. This type of gravitational relationship is not unique to our planet. Many moons throughout the solar system are tidally locked to the planets they orbit. For example, several moons orbiting the giant planet Jupiter show the same face to their parent planet at all times. Similar behavior occurs among moons orbiting Saturn and other giant planets. However, because Earth's moon appears so large in our sky, the effect is particularly noticeable to observers on Earth. For thousands of years, the hidden hemisphere of the moon remained completely unknown. even the most powerful telescopes could not reveal what lay beyond the visible edge. Astronomers could map the craters and plains on the near side with increasing accuracy, yet the far side remained one of the greatest unexplored landscapes in astronomy. Some early scientists speculated that the hidden hemisphere might look very similar to the side facing Earth. Others wondered if it might contain completely different geological features. The mystery remained unsolved until the beginning of the space age. On October 7, 1959, the Soviet spacecraft Lunar 3 made history by photographing the far side of the moon for the first time. As the spacecraft traveled behind the moon, it captured a series of grainy black and white images using onboard cameras. The images were developed inside the spacecraft and then transmitted back to Earth using early radio technology. When scientists on Earth finally saw the photographs, they realized that the hidden hemisphere looked nothing like they expected. The far side of the moon was dramatically different from the familiar surface seen from Earth. The near side of the moon contains large dark plains called lunar maria. These maria formed billions of years ago when molten lava flooded enormous impact basins. Over time, the lava cooled into smooth, basaltic plains that appear darker than the surrounding terrain. These dark patches form the patterns that people often interpret as shapes or faces on the moon. In contrast, the far side of the moon contains very few maria. Instead, its surface is dominated by rugged highlands covered with dense impact craters. Scientists quickly realized that the two hemispheres of the moon have very different geological histories. The near side contains vast lava plains that formed during ancient volcanic activity. These plains suggest that molten rock once flowed across large regions of the lunar surface. The far side, however, preserved a much older landscape. Its surface appears heavily cratered and relatively unchanged for billions of years. One explanation for this difference involves the thickness of the lunar crust. Measurements from later spacecraft missions revealed that the crust on the far side of the moon is significantly thicker than the crust on the near side. A thicker crust would make it more difficult for molten material from the moon's interior to reach the surface. As a result, large volcanic eruptions would have been less likely on the far side. Without these eruptions filling impact basins with lava, the ancient craters remain visible. The far side also contains one of the most dramatic impact structures in the solar system. This feature is known as the South Pole Aitken Basin. Stretching roughly 2,500 kilometers across, it is one of the largest and oldest known impact basins in the solar system. The basin extends from the moon's south pole deep into the far side hemisphere. Scientists believe it formed more than 4 billion years ago when a massive asteroid slammed into the moon with incredible force. The impact that created this basin was so powerful that it excavated material from deep within the moon's interior. Some scientists believe rocks exposed inside the basin may originate from the moon's mantle. Studying these materials could reveal new clues about the moon's internal composition. Because of this possibility, the South Pole Aitken Basin has become one of the most important targets for future lunar exploration. Despite decades of study, scientists still debate exactly why the moon's two hemispheres evolved so differently. One hypothesis suggests that conditions during the moon's early formation created a temperature difference between the two sides. When the moon was young and partially molten, one hemisphere constantly faced Earth due to early tidal interactions. Earth's heat may have warmed the near side of the moon slightly, slowing the cooling of its crust. This difference might have allowed magma to rise more easily on the near side, producing the large volcanic plains we see today. Another possibility involves the distribution of radioactive elements within the moon's crust. Certain elements, such as uranium and thorium, produce heat as they decay. If these elements were concentrated more heavily on the near side, they could have maintained volcanic activity there for longer periods. This explanation remains an active area of research among planetary scientists. Modern spacecraft have continued exploring the far side in greater detail. Orbiting satellites have mapped its surface with high-resolution cameras and radar instruments. These missions revealed countless impact craters, mountain ranges, and complex geological structures. However, landing on the far side presents unique challenges. Because the moon blocks direct radio signals, spacecraft on the far side cannot communicate directly with Earth. In 2019, the Chinese spacecraft Chang'e 4 successfully became the first mission to land on the far side of the moon. The lander touched down inside the von Karman crater, which lies within the South Pole Aitken Basin. To maintain communication with Earth, China launched a relay satellite called Queqiao into orbit around the moon. This satellite relayed signals between the lander and mission control on Earth. The Chang'e 4 mission provided valuable new data about the far side's geology. Instruments on board the lander studied lunar soil composition, radiation levels, and subsurface structures. These measurements helped scientists better understand the differences between the moon's 2 hemispheres. Some regions of the far side may contain materials excavated from deep within the lunar mantle during ancient impacts. Despite these advances, the far side of the moon still holds many unanswered questions. Its thick crust, unusual chemical composition, and ancient impact structures all hint at a complex geological history. Studying this hidden hemisphere may reveal new information about how the moon formed and how it evolved over billions of years. Yet one of the most surprising discoveries about the moon came not from photographs, but from vibrations deep within its interior. During the Apollo missions, scientists conducted experiments designed to study the moon's internal structure. In several cases, spacecraft stages were deliberately crashed into the lunar surface while seismometers recorded the resulting vibrations. Researchers expected the vibrations to fade quickly, much like earthquakes do on Earth. Instead, the moon behaved in a very unexpected way. The vibrations continued for an unusually long time, echoing through the lunar interior, almost like the ringing of a bell. By the late 1960s, the Apollo missions had already achieved one of humanity's greatest milestones. Astronauts had landed on the moon and safely returned to Earth. Yet landing humans on the lunar surface was never the final scientific goal. For researchers studying planetary science, the moon offered something even more valuable. It provided a natural laboratory for understanding how rocky worlds form and evolve. Scientists hoped that careful experiments on the moon would reveal details about its internal structure and geological history. One of the most powerful tools for this investigation was lunar seismology. Seismology is the study of vibrations traveling through a planetary body. On Earth, earthquakes generate seismic waves that move through the planet's interior. By analyzing how these waves travel, scientists can determine whether they pass through solid rock, liquid layers, or metallic cores. This technique has allowed geologists to map the layered structure of Earth with remarkable accuracy. Researchers believe the same approach could reveal what lay beneath the moon's surface. If the moon experienced impacts or internal movements, seismic instruments might capture the vibrations and provide clues about its interior. The first attempt to study lunar vibrations occurred during the historic Apollo 11 mission in July 1969. Astronauts Neil Armstrong and Buzz Aldrin placed a small seismometer on the surface near their landing site in the Sea of Tranquility. This instrument was designed to record tiny vibrations caused by meteor impacts or shifts in the lunar crust. The seismometer successfully transmitted data for several weeks. Unfortunately, the instrument eventually stopped working when its power supply failed under the extreme lunar conditions. Despite this short operation, the early experiment proved that seismic measurements on the moon were possible. Scientists quickly realized that more advanced instruments would be needed to conduct long-term studies. Later missions carried improved versions of these devices as part of a collection of scientific instruments called the Apollo Lunar Surface Experiments Package. These packages were left on the moon's surface to continue transmitting data long after the astronauts had departed. A particularly important experiment occurred during the Apollo 12 mission in November 1969. Astronauts deployed a much more sophisticated seismometer designed to operate for years. Scientists then performed a controlled experiment to observe how the moon responded to a powerful impact. Engineers directed the empty upper stage of the Saturn V rocket to crash into the moon's surface at high speed. The collision occurred hundreds of kilometers away from the seismometer. When the rocket stage struck the lunar surface, the seismometer immediately recorded the vibrations. Scientists expected the seismic waves to behave similarly to earthquakes on Earth. Normally, vibrations caused by an impact fade quickly as energy dissipates through rock and soil. Instead, the lunar instrument detected something unusual. The seismic signals continued far longer than expected. Rather than fading within a few minutes, the vibrations persisted for nearly an hour. Researchers studying the data were astonished by the result. The waves seemed to reverberate through the moon's interior, reflecting back and forth for an extended period of time. One scientist famously described the effect by saying that the moon rang like a bell. The phrase quickly became one of the most memorable descriptions of lunar behavior during the Apollo program. This unexpected observation raised new questions about the moon's internal structure. On Earth, seismic waves lose energy quickly because our planet contains water, molten rock, and complex geological layers. These materials absorb vibrations and convert the energy into heat. The moon, however, appeared to behave differently. Its interior seemed capable of transmitting vibrations much farther without losing energy. This suggested that the moon's internal composition was significantly different from Earth's. Similar experiments were repeated during later Apollo missions. During Apollo 13, Apollo 14, Apollo 15, and Apollo 17, additional seismometers were placed on the lunar surface. In several cases, discarded rocket stages or lunar modules were intentionally crashed into the moon. Each impact produced seismic signals that were carefully recorded by the instruments. Once again, scientists noticed that the vibrations persisted much longer than expected. These results suggested that the moon's interior was extremely dry and rigid. Unlike Earth, the moon contains almost no liquid water within its crust. Water on Earth acts as an efficient absorber of seismic energy. Without water to dampen vibrations, seismic waves can travel farther and reflect repeatedly through the lunar crust. In addition, billions of years of meteor impacts have fractured the moon's outer layers into a network of cracks and faults. These fractures can reflect seismic waves, allowing them to bounce through the crust like echoes in a cavern. Despite these scientific explanations, the phrase "rang like a bell" captured the public imagination in unexpected ways. During the 1970s, several speculative writers began suggesting that the moon might be hollow inside. According to these ideas, the long-lasting vibrations recorded during Apollo experiments indicated that the moon might contain a vast, empty interior. Some even proposed that the moon might be an artificial structure created by an advanced civilization. These theories gained popularity in certain science fiction and fringe literature during the Cold War era. One of the most widely discussed versions appeared in books suggesting that the moon might be a giant alien spacecraft placed in orbit around Earth. Supporters of these ideas argued that the unusual seismic behavior and certain geological features hinted at artificial construction. Although these claims attracted public attention, they were never supported by scientific evidence. Planetary scientists studying the Apollo seismic data reached very different conclusions. Careful analysis showed that the moon's internal structure is consistent with a natural rocky body. Beneath the surface lies a layered interior consisting of a crust, a mantle, and a small core. The lunar crust is estimated to be between 30 and 60 kilometers thick in most regions. Beneath this crust lies a mantle composed of dense silicate minerals similar to those found in Earth's mantle. At the center of the Moon lies a small metallic core. Modern measurements suggest that this core has a radius of roughly 350 kilometers. While this is tiny compared to Earth's core, it confirms that the Moon contains a layered internal structure like other rocky planets. Evidence from seismic experiments and later spacecraft observations indicates that part of this core may even be partially molten. One reason the Moon behaves differently during seismic events is the extreme dryness of its interior. Without water or large molten regions near the surface, seismic waves encounter fewer obstacles that would normally absorb energy. Instead of dissipating quickly, the waves travel long distances through the crust and mantle. The fractured nature of the lunar crust also allows waves to reflect repeatedly within the interior, extending the duration of the vibrations. Later missions helped refine this understanding even further. Data collected by lunar orbiters and seismic instruments revealed that the Moon experiences small natural quakes known as moonquakes. Some of these quakes occur deep within the Moon's interior, while others are triggered by the tidal pool of Earth's gravity. Although these quakes are typically weaker than earthquakes on Earth, they can still produce measurable vibrations across the lunar surface. The Apollo seismic network operated for several years, providing a wealth of data about the Moon's internal behavior. These measurements helped scientists estimate the thickness of the lunar crust and the properties of the mantle beneath it. By analyzing how seismic waves traveled through different layers, researchers were able to construct detailed models of the Moon's internal structure. The results consistently supported the conclusion that the Moon is solid and layered rather than hollow. Even so, the unusual seismic behavior remains one of the most fascinating discoveries from the Apollo era. The Moon's dry and rigid interior gives it properties unlike those of Earth. Instead of absorbing vibrations quickly, the Moon allows seismic waves to travel great distances and echo through its crust. In some ways, this makes the Moon behave more like a giant, resonating crystal than a damp and flexible planet. Scientific discoveries often inspire imaginative speculation, especially when the phenomena appear unusual at first glance. The idea of a hollow moon captured public attention because it seemed to offer a dramatic explanation for the Apollo observations. Yet the real scientific story turned out to be equally fascinating. By studying how the Moon responds to impacts and vibrations, scientists gained valuable insight into its structure and evolution. These experiments revealed that the Moon's interior contains layers formed during its early history. They also showed that the Moon's crust has been fractured by billions of years of asteroid impacts. Each piece of seismic data helped scientists better understand how the Moon formed and how its internal structure developed over time. Yet while the Moon's interior has now been studied in considerable detail, the lunar surface still contains many mysteries of its own. Over the decades, countless photographs of the Moon have circulated across books, magazines, and the internet. Some images appear to show strange shapes, unusual patterns, or geometric formations scattered across the landscape. For some observers, these photographs hint at something extraordinary hidden on the Moon's surface. Long before spacecraft ever traveled to the Moon, astronomers studying the lunar surface sometimes noticed shapes that seemed unusual or difficult to explain at first glance. When the first telescopes were pointed toward the Moon during the early 17th century, observers began mapping a landscape unlike anything found on Earth. The Italian astronomer Galileo Galilei was among the first to carefully examine the Moon using a telescope. In 1610, Galileo described a rugged terrain filled with mountains, valleys, and enormous circular depressions. His observations proved that the Moon was not a perfectly smooth sphere as earlier philosophers had believed. Around the same period, the Polish astronomer Johannes Hevelius produced one of the earliest detailed lunar maps. Using telescopes far less powerful than modern instruments, Hevelius recorded hundreds of visible features across the lunar surface. These early maps revealed mountain ranges, crater chains, and wide plains that appeared darker than the surrounding terrain. Although most features could be explained as natural formations, some shapes appeared surprisingly geometric under certain lighting conditions. These unusual patterns sparked curiosity among early astronomers who were still trying to understand the moon's geology. As telescopes improved during the 19th century, astronomers began recording lunar features with increasing accuracy. Powerful observatories allowed scientists to study the moon in greater detail than ever before. Observers occasionally reported seeing triangular peaks, long straight ridges, or formations that appeared almost symmetrical. At first glance, some of these structures seemed unusually ordered for a natural landscape. However, most scientists concluded that these shapes were simply the result of natural geological processes such as asteroid impacts and volcanic activity. The moon's surface was shaped by billions of years of violent events. Meteorites and asteroids repeatedly struck the lunar crust, producing enormous craters and mountains of shattered rock. Lava flows later filled some of these impact basins, creating smooth plains known as maria. These processes can generate terrain with striking shapes that sometimes appear artificial when viewed from certain angles. Even on Earth, natural landscapes occasionally produce formations that look remarkably geometric. Interest in unusual lunar formations increased dramatically during the space age. In the 1960s, the United States and the Soviet Union began sending robotic spacecraft to photograph the moon in preparation for human exploration. Missions such as the Lunar Orbiter program and the Surveyor program captured thousands of high-resolution images of the lunar surface. For the first time, scientists could examine the moon's terrain in extraordinary detail. These photographs revealed countless craters, cliffs, lava plains, and complex geological structures. Among these images were a few formations that attracted unusual attention. One example became known as the Blair Cuspid. These formations appeared in photographs taken during the Apollo era and seemed to show tall, sharp peaks rising dramatically above the lunar surface. Some observers described them as resembling towers or narrow spires. When viewed under low-angle sunlight, the peaks cast extremely long shadows across the surrounding terrain. These shadows exaggerated the height and shape of the structures, making them appear even more dramatic. Later analysis revealed that the Blair Cuspids were simply natural mountains formed by impact processes. The sharp shapes resulted from erosion caused by countless smaller impacts over billions of years. Without an atmosphere or flowing water to smooth the terrain, lunar mountains can remain jagged and steep for extremely long periods of time. Under the right lighting conditions, these peaks can appear almost artificial when photographed from orbit. Another source of curiosity came from images captured during the Lunar Orbiter missions between 1966 and 1967. Some photographs appeared to show long straight lines or rectangular patterns across the lunar surface. These features initially puzzled observers because natural landscapes on Earth rarely produce perfectly straight structures over large distances. However, geologists later explained that these formations were likely fractures in the lunar crust. When large impacts strike the moon, the energy released can fracture the surrounding rock into enormous blocks. As these blocks shift and settle, they sometimes form long linear ridges or cracks known as grabens. These fractures can extend for dozens or even hundreds of kilometers across the surface. From certain angles, the edges of these features can appear surprisingly straight in photographs. When combined with shadows cast by sunlight, they can create shapes that resemble walls or artificial structures. One of the regions that has attracted particular attention is the Aristarchus Plateau. This bright and geologically complex region contains volcanic deposits, deep valleys, and collapsed lava tubes. The plateau stands out strongly against the darker surrounding plains. Under certain lighting conditions, the interplay of sunlight and shadow across this rugged terrain can create striking visual patterns. Some photographs of the region have circulated online showing shapes that appear almost architectural. At first glance, these formations can resemble towers, pyramids, or rectangular buildings. Scientists studying the region emphasize that these shapes arise from entirely natural processes. Volcanic eruptions, lava flows, and subsequent impacts have sculpted the plateau over billions of years. The human brain, however, is extremely good at recognizing patterns, even where none were intentionally created. This psychological tendency is known as pareidolia. It explains why people sometimes see faces in clouds or animals in rock formations. When applied to lunar imagery, pareidolia can cause observers to interpret natural terrain as artificial structures. Lighting conditions play a major role in creating these illusions. The moon has no atmosphere to scatter sunlight. As a result, shadows on the lunar surface are extremely sharp and well-defined. When the sun sits low above the horizon, small ridges and hills cast long shadows across the ground. These shadows can exaggerate the apparent size of surface features and produce dramatic shapes in photographs. A mound only a few meters tall may cast a shadow stretching hundreds of meters across the landscape. Another factor contributing to lunar anomaly claims is image resolution. Early photographs taken during the 1960s and 1970s were limited by the technology available at the time. Some images contained grainy textures or distortions caused by the photographic equipment used in space. When these images were enlarged or reprocessed decades later, certain details appeared ambiguous or unusual. Without higher resolution data, it was easy for observers to misinterpret natural features as something mysterious. Modern spacecraft have dramatically improved our view of the moon. One of the most important missions in recent years is the Lunar Reconnaissance Orbiter launched by NASA in 2009. This spacecraft carries cameras capable of photographing the lunar surface with extraordinary clarity. Some images reveal details as small as a few meters across. Using these high-resolution photographs, scientists have been able to re-examine many earlier claims of unusual lunar structures. In nearly every case, the mysterious formations turn out to be ordinary geological features when viewed at higher resolution. Craters that once appeared square or rectangular reveal themselves as irregular impact structures. Linear ridges become clearly identifiable as tectonic fractures. Shadow patterns that once resembled towers or buildings resolve into natural hills and cliffs. These observations demonstrate how easily the human eye can misinterpret unfamiliar landscapes. Despite scientific explanations, interest in lunar anomalies has never completely disappeared. The moon's surface remains a place of dramatic contrasts and strange shapes. Billions of years of impacts, volcanic eruptions, and tectonic stresses have produced a landscape unlike any found on Earth. In some regions, the terrain is so complex that it can easily inspire imaginative interpretations. In recent decades, the rise of the internet has amplified public interest in these unusual formations. High-resolution spacecraft images are now freely available online, allowing anyone to explore the moon's surface in remarkable detail. Amateur observers often examine these images closely, searching for unusual patterns or unexplained structures. When an interesting formation is discovered, it can quickly spread across online communities and social media platforms. While many of these interpretations are incorrect, they reveal something important about human curiosity. People have always been fascinated by the possibility that the moon might hold secrets beyond our current understanding. Every unusual photograph invites speculation about what might lie hidden among the craters and mountains. For scientists, these anomalies serve as reminders that extraterrestrial landscapes can appear strange simply because they are unfamiliar. Geological processes operating in different environments can produce formations that look unusual to human observers. When studied carefully, however, these structures almost always reveal natural explanations rooted in planetary science. Yet even as scientists explain these formations, the fascination they inspire continues to grow. The Moon remains the closest celestial body to Earth and one of the most heavily studied objects in the solar system. Still, its strange surface features often spark imaginative theories about what might exist beyond ordinary geology. Some of those theories take the idea even further. Instead of focusing on unusual shapes on the lunar surface, a few writers have suggested something far more dramatic. According to these ideas, the Moon itself might not be entirely natural. Some have proposed that it could be an artificial satellite placed into orbit around Earth by an advanced civilization long ago. The next chapter explores this controversial idea and the reasons why it continues to attract attention despite overwhelming scientific skepticism. Throughout human history, the Moon has inspired myths, legends, and speculation about its true nature. Ancient civilizations often imagined it as a divine object or a celestial realm inhabited by gods. Even after the scientific revolution transformed astronomy, the Moon continued to spark curiosity about its origin and purpose. In the 20th century, a particularly controversial idea began circulating in popular culture. According to this concept, the Moon might not be a natural object at all. Instead, some writers proposed that it could be an artificial structure placed in orbit around Earth by an advanced civilization long ago. This idea eventually became known as the artificial moon hypothesis. The artificial moon concept first gained widespread attention during the early years of the space age. In 1970, Soviet scientists Mikhail Vasin and Alexander Shcherbakov published an article discussing unusual properties of the Moon. Their work appeared in the Soviet science journal Sputnik and was later translated into several languages. In the article, the authors suggested that some characteristics of the Moon seemed unusual enough to inspire speculation. Rather than presenting a fully developed theory, they posed a provocative question. What if the Moon were actually a gigantic artificial satellite created by an advanced extraterrestrial civilization? Vasin and Shcherbakov speculated that the Moon might be a hollow megastructure containing an internal framework or shell. They proposed that such a structure could have been built by extraterrestrial engineers long before human civilization existed. According to their interpretation, the Moon might have been placed into orbit around Earth deliberately. In their view, it could serve as a monitoring platform or a long-term observation station for studying the development of life on our planet. One of the arguments occasionally cited by supporters of the artificial moon idea involves the Moon's unusual size relative to Earth. As discussed earlier, the Moon is exceptionally large compared with most moons orbiting rocky planets. In fact, its diameter is more than 1/4 that of Earth. When planetary scientists compare this ratio to other moons in the solar system, the Earth-Moon pair stands out as somewhat unusual. Vasin and Shcherbakov suggested that such an unusual size relationship might indicate intentional placement rather than natural formation. However, planetary scientists emphasize that unusual does not mean impossible. The giant impact theory described in earlier chapters provides a well-supported explanation for why the Moon is so large relative to Earth. According to this model, the Moon formed from debris produced when a Mars-sized protoplanet collided with the young Earth. Because much of this material came from Earth's outer layers, the resulting Moon naturally ended up relatively large compared with its parent planet. Computer simulations of this impact reproduce the Moon's size and orbit with remarkable accuracy. Another point sometimes raised in artificial moon discussions involves the stability of the Moon's orbit. The Moon travels around Earth at an average distance of about 384,400 kilometers and maintains a remarkably consistent orbital pattern. Some theorists argue that this stability might indicate deliberate positioning. In reality, orbital stability arises naturally through gravitational physics. Over billions of years, the Earth-Moon system has settled into a stable configuration governed by the laws of celestial mechanics. The Moon's orbit slowly evolves due to tidal interactions, but the overall system remains stable without requiring artificial intervention. Supporters of the artificial moon hypothesis have also pointed to the Apollo seismic experiments discussed in the previous chapter, when rocket stages were deliberately crashed into the moon during several Apollo missions. The resulting vibrations lasted longer than scientists initially expected. Researchers described the effect by saying that the moon rang like a bell. Some theorists interpreted this phrase literally and suggested that the moon might contain a large, hollow interior. Modern seismic analysis does not support this interpretation. Data collected from multiple Apollo seismometers revealed that the moon possesses a layered internal structure similar to other rocky bodies. Beneath the lunar crust lies a mantle composed of dense silicate minerals. At the center is a small metallic core with a radius of roughly 350 kilometers. These measurements confirm that the moon is a solid celestial body rather than a hollow shell. Another argument sometimes mentioned in artificial moon discussions involves solar eclipses. From Earth's perspective, the moon and the sun appear almost exactly the same size in the sky. This remarkable coincidence allows the moon to completely cover the sun during total solar eclipses. Some theorists have suggested that this alignment might be too precise to occur naturally. They argue that the moon may have been intentionally positioned to create this phenomenon. Astronomers explain that this alignment results from simple geometry rather than design. The sun is about 400 times larger than the moon in diameter. However, it is also roughly 400 times farther away from Earth. These ratios cause the two objects to appear nearly the same size in our sky. This alignment is temporary on geological timescales. Because the moon is slowly moving away from Earth at a rate of about 3.8 centimeters per year, total solar eclipses will eventually disappear millions of years in the future. The idea of an artificial moon also gained momentum through science fiction and speculative literature. In the mid-20th century, authors explored imaginative possibilities involving extraterrestrial technology and cosmic engineering. The famous science fiction writer Isaac Asimov occasionally commented on the unusual characteristics of the moon in his essays. Asimov pointed out that the moon was unusually large relative to Earth and that its formation remained an important scientific puzzle. However, he never suggested that the moon was artificial. Instead, his observations highlighted how intriguing the moon's properties appeared before the giant impact theory became widely accepted. During the 1970s and 1980s, several speculative books expanded upon the artificial moon concept. Some writers proposed that the moon might be a gigantic observation station designed to monitor Earth's biosphere. Others imagined that it could be the remains of an ancient alien spacecraft or a relic from a lost extraterrestrial civilization. These ideas were often presented in sensational ways that captured public attention but lacked scientific support. Despite the popularity of such ideas in certain circles, scientists overwhelmingly reject the artificial moon hypothesis. The evidence gathered from decades of lunar exploration strongly supports the conclusion that the moon formed through natural planetary processes. Samples collected during the Apollo missions show clear signs of volcanic activity, impact melting, and crystallization, typical of natural rock formation. The chemical composition of lunar rocks closely matches Earth's mantle, consistent with the giant impact model. Spacecraft measurements also confirm the moon's gravitational properties and internal structure. Missions such as Grail mapped the moon's gravitational field in remarkable detail. These measurements revealed variations caused by dense regions of rock beneath the lunar surface. The patterns observed are consistent with natural geological processes rather than artificial construction. If the moon contained vast hollow cavities or engineered structures, they would produce detectable gravitational anomalies. No such evidence has been found. The persistence of artificial moon theories reveals something interesting about human psychology. Humans are naturally drawn to mysteries and unusual coincidences. When a celestial object appears large and prominent in the night sky, it easily becomes the focus of imagination and speculation. The moon has played this role in human culture for thousands of years. Stories about the moon appear in myths, folklore, and literature across many civilizations. Even today, the moon continues to inspire curiosity and wonder. Its surface still contains unexplored regions and geological features that scientists are only beginning to understand. Future missions will continue studying its composition, interior structure, and potential resources. Each new discovery helps refine our understanding of how the moon formed and evolved over billions of years. Although the artificial moon hypothesis does not withstand scientific scrutiny, it reflects the enduring fascination people feel toward Earth's closest celestial neighbor. The moon may not be an alien megastructure, but it remains one of the most remarkable objects in the solar system. Its origin story involves colossal impacts, molten oceans of rock, and billions of years of geological change. Understanding the moon requires studying it with careful scientific investigation rather than speculation. Researchers continue examining lunar rocks, mapping the surface with spacecraft, and analyzing gravitational data to uncover new details about its history. Each piece of evidence brings us closer to understanding how the moon formed and how it continues to evolve. Yet even after decades of exploration, one fundamental question remains: what exactly lies deep inside the moon? The answer may reveal even more surprising insights about the structure and evolution of our closest cosmic companion. For most of human history, the moon's interior remained completely mysterious. Astronomers could observe the craters and plains scattered across its surface, yet what lay beneath that gray landscape was unknown. Even after humans first landed on the moon during the Apollo missions, scientists could only infer the moon's internal structure indirectly. Unlike Earth, where drilling and geological processes reveal subsurface layers, the moon offered few direct clues about its hidden interior. Understanding what lies inside the moon became a central challenge for planetary science. The answer would reveal not only how the moon formed, but also how rocky worlds evolve across the solar system. One of the most powerful tools for studying planetary interiors is seismology. On Earth, earthquakes send seismic waves traveling through the planet. These waves move differently through solid rock, molten layers, and metallic cores. By measuring the speed and direction of these waves, scientists can map the structure of Earth's interior. Planetary scientists hope to apply the same method to the moon. If seismic vibrations could be detected on the lunar surface, they might reveal the internal layers hidden beneath the crust. The first lunar seismology experiments began during the Apollo era. Starting with the Apollo 11 mission in 1969, astronauts placed sensitive seismometers on the lunar surface. Later missions expanded this network of instruments. The seismometers became part of the Apollo Lunar Surface Experiments package, a set of scientific instruments designed to continue operating after the astronauts returned to Earth. These devices monitored the moon for nearly 8 years, recording vibrations from impacts and internal movements. During that time, scientists discovered that the moon experiences several different types of seismic activity known as moonquakes. Some of these quakes occur when meteoroids strike the lunar surface. Because the moon lacks an atmosphere, even small pieces of space debris can impact the ground at high speed. These impacts produce vibrations that travel through the lunar crust. Other moonquakes result from tidal stresses caused by Earth's gravity. As the moon orbits Earth, gravitational forces slightly flex its interior, occasionally triggering seismic events. Perhaps the most intriguing moonquakes occur deep within the moon itself. These deep moonquakes originate hundreds of kilometers below the surface and repeat in regular patterns linked to the moon's orbit around Earth. Their predictable timing suggests that tidal forces play a major role in triggering them. By studying how seismic waves from these events traveled through the moon, scientists began constructing the first models of its internal structure. Early results revealed that the moon has a layered interior similar to Earth's, although far simpler. The outermost layer is the lunar crust. This crust consists primarily of light-colored rocks called anorthosites that formed during the moon's early cooling. Measurements from spacecraft and seismic data suggest that the crust averages roughly 50 kilometers thick on the near side. On the far side, however, it can exceed 100 kilometers in thickness. This difference in crustal thickness helps explain why volcanic activity occurred mainly on the near side billions of years ago. Beneath the crust lies the lunar mantle, a thick layer composed mostly of magnesium and iron-rich silicate minerals. The mantle accounts for the majority of the moon's internal volume. When the moon was young, this mantle was much hotter and partially molten in some regions. Magma rising from the mantle produced volcanic eruptions that flooded giant impact basins with basaltic lava. These ancient lava flows created the dark plains known as lunar maria that are visible from Earth. For many years, scientists were uncertain whether the moon possessed a core similar to Earth's. Earth's core plays a crucial role in our planet's geology. The outer core consists of molten iron and nickel, which generates Earth's magnetic field through a process called the geodynamo. This magnetic field protects our planet from harmful solar radiation. The moon, however, shows little evidence of a strong global magnetic field today. This led some early researchers to believe that the moon might lack a significant core altogether. New evidence began to emerge as scientists revisited Apollo seismic data using modern computing techniques. Improvements in data analysis allowed researchers to detect subtle seismic signals that had previously gone unnoticed. These signals suggested that seismic waves were reflecting from a boundary deep inside the moon. Such reflections hinted at the presence of a core with different physical properties than the surrounding mantle. Today, most scientists agree that the moon does contain a small core. Estimates suggest that this core has a radius of roughly 350 kilometers. Compared with Earth's massive core, this is extremely small. The lunar core likely consists primarily of iron mixed with smaller amounts of sulfur and other elements. Surrounding the solid inner core may be a thin layer of molten metal known as a liquid outer core. This structure resembles Earth's core but on a much smaller scale. Understanding the size and composition of the lunar core helps explain another mystery. Ancient lunar rocks studied during the Apollo missions contain evidence that the moon once possessed a weak magnetic field billions of years ago. This field may have been generated by motion within the molten portion of the core. As the moon gradually cooled, the core likely solidified enough to shut down this ancient magnetic dynamo. While seismic data revealed important clues about the moon's interior, spacecraft missions have also played a critical role in studying its hidden structure. One of the most important of these missions was the Grail mission launched by NASA in 2011. Grail consisted of two spacecraft named Ebb and Flow that orbited the moon together in a carefully coordinated formation. As they flew over the lunar surface, the spacecraft measured tiny variations in the moon's gravitational field. These gravitational measurements revealed the distribution of mass beneath the lunar surface with unprecedented precision. One of the most important discoveries involved large regions of unusually dense material buried beneath certain impact basins. Scientists refer to these regions as mass cones, short for mass concentrations. Mass cones formed billions of years ago when enormous asteroids struck the moon, creating vast basins several hundred kilometers wide. When these massive impacts occurred, they excavated enormous amounts of crustal material and compressed the mantle beneath the basin. Later, volcanic eruptions filled the basins with dense basaltic lava. The combined effect created regions where mass was concentrated more heavily than in surrounding terrain. These dense regions alter the moon's gravitational field in subtle ways. Mass cones were first noticed during the early days of lunar exploration. In the 1960s, engineers studying spacecraft trajectories noticed something unusual. Spacecraft orbiting the Moon sometimes experienced unexpected changes in their paths. When passing over certain regions, their orbits shifted slightly due to variations in gravitational pull. Later analysis showed that these shifts occurred above major impact basins containing mascons. The Grail mission provided the most detailed maps of these gravitational anomalies ever produced. By studying the distribution of mascons, scientists gained new insights into the Moon's internal structure and geological history. These measurements also helped researchers refine models of how the Moon cooled and evolved after its formation. The Moon's interior today is far less active than it was billions of years ago. Most volcanic activity ended more than 3 billion years in the past. The mantle has cooled significantly, and molten rock rarely reaches the surface. However, the Moon is not completely inactive. Small moonquakes still occur occasionally as tidal forces from Earth flex the lunar crust. Some quakes originate deep within the mantle, while others occur near the surface as the Moon's crust expands and contracts due to temperature changes. Studying these subtle seismic events continues to reveal new information about the Moon's internal structure. Each vibration traveling through the lunar interior provides another data point for scientists mapping its hidden layers. Future missions may deploy new networks of seismometers across the Moon, allowing researchers to measure moonquakes with far greater accuracy than was possible during the Apollo era. Understanding the Moon's internal structure is also crucial for reconstructing its formation. The distribution of crust, mantle, and core materials preserves evidence of the giant impact that created the Moon billions of years ago. By comparing seismic and gravitational data with computer simulations, scientists can refine their models of how the debris from that colossal collision eventually formed the Moon we see today. Even with decades of research, many mysteries remain. Scientists continue debating the exact size of the lunar core and the composition of the deep mantle. Some models suggest that the core may contain additional layers not yet fully understood. Others propose that pockets of partially molten rock may still exist deep within the Moon. Each new mission brings researchers closer to answering these questions. Yet the Moon continues to surprise scientists with discoveries that challenge earlier assumptions. For centuries, astronomers believed the Moon was completely dry and barren. Its gray surface seemed to show no signs of water or ice. That assumption turned out to be wrong. Hidden within the darkest craters near the lunar poles, scientists have discovered something remarkable: evidence that water may exist on the Moon after all. For centuries, scientists believed the Moon was completely dry. Early telescopic observations revealed a barren world of craters, mountains, and dark volcanic plains. No rivers carved through its surface. No clouds drifted across its sky. The Moon appeared silent and lifeless, a dusty companion orbiting Earth with no sign of water. When astronauts first stepped onto the lunar surface during the Apollo missions, this assumption seemed confirmed. The rocks and soil they collected showed no visible moisture. The environment appeared extremely dry, reinforcing the idea that the Moon had long ago lost any water it might once have contained. This belief made sense according to early theories of lunar formation. The giant impact that likely created the Moon would have generated immense heat. During such a violent collision, most volatile materials, including water, would have evaporated into space. Any remaining moisture would likely have been driven away by the intense heat of the early lunar surface. As a result, scientists assumed the Moon had become completely dehydrated during its formation. For decades, this explanation remained widely accepted. However, planetary science began entering a new era in the late 20th century. Advances in spacecraft technology allowed scientists to study the Moon in far greater detail than ever before. Instruments capable of detecting subtle chemical signatures were now being sent into lunar orbit. These missions began revealing clues that challenged long-held assumptions about the Moon's composition. One of the first hints that the moon might contain water appeared during the mission of Clementine in 1994. This spacecraft was a joint project between NASA and the U.S. Department of Defense. Clementine spent several months orbiting the moon while mapping its surface with cameras and radar instruments. During this mission, scientists conducted a radar experiment focused on the lunar poles. They directed radar signals toward permanently shadowed craters and measured how those signals reflected back into space. The results were unexpected. Certain regions near the moon's south pole produced radar reflections that behaved similarly to reflections from ice on Earth. These signals suggested that something beneath the lunar surface might be reflecting radar waves in a distinctive way. At first, researchers were cautious about interpreting the data. Radar reflections can be produced by several different materials, yet the possibility that ice might exist on the moon suddenly became a serious scientific question. To understand why ice might survive on the moon, scientists turned their attention to the extreme environment of the lunar poles. Unlike Earth, the moon has almost no axial tilt. As a result, sunlight strikes the polar regions at a very shallow angle. Deep craters near the poles contain areas that never receive direct sunlight. These permanently shadowed regions remain in darkness for billions of years. Temperatures inside these craters can drop below -200 degrees Celsius. Such frigid conditions create what scientists call cold traps. In these regions, water molecules that arrive on the moon could become frozen and remain preserved indefinitely. Even though most of the lunar surface experiences intense heat during the day, these shadowed craters provide natural storage sites where ice could accumulate over immense periods of time. Further evidence for lunar water emerged in 1998 with the launch of Lunar Prospector. This spacecraft carried instruments designed to measure the abundance of hydrogen on the moon. Because hydrogen is a key component of water molecules, detecting hydrogen concentrations could indicate the presence of ice. As Lunar Prospector orbited the moon, its neutron spectrometer detected unusually high levels of hydrogen near both lunar poles. The data suggested that significant quantities of hydrogen were trapped within the soil surrounding polar craters. Scientists interpreted this as strong evidence that water ice might exist beneath the surface. Although the spacecraft could not directly observe the ice itself, the hydrogen measurements provided compelling indirect support for its presence. The most dramatic confirmation arrived more than a decade later during the mission of Alcross in 2009. This mission was specifically designed to test whether water existed in permanently shadowed craters. The experiment involved deliberately crashing a spent rocket stage into a dark crater near the lunar south pole. The impact occurred inside Cabeus crater, one of the coldest locations on the moon. As the rocket stage slammed into the surface, it produced a plume of debris that rose high above the crater rim. A trailing spacecraft flew through this plume and analyzed the material using spectrometers and other instruments. Scientists watching the data in real time soon saw unmistakable signatures of water vapor and ice particles. The plume also contained traces of carbon dioxide, methane, ammonia, and other volatile compounds. The discovery confirmed that water existed within the lunar soil. Researchers estimated that some areas of the crater contained several percent water by weight. Although this might sound small, it represents a significant amount of ice when spread across large regions of the polar surface. For the first time, scientists had direct evidence that the moon contains frozen water. Around the same time, another spacecraft provided additional confirmation. India's lunar probe, Chandrayaan-1, carried an instrument known as the Moon Mineralogy Mapper. This device measured how sunlight reflected from minerals on the lunar surface. The instrument detected spectral signatures indicating the presence of hydroxyl and water molecules embedded within the lunar soil. These molecules appeared across large portions of the moon's surface, not just in polar craters. Unlike the thick ice deposits believed to exist in permanently shadowed regions, these molecules were present in extremely small quantities. They formed when hydrogen from the solar wind interacted with oxygen atoms in lunar minerals. When charged hydrogen particles from the sun strike the moon's surface, they can bond with oxygen in the rock to create hydroxyl groups or water molecules. This process suggests that water on the moon may be continuously generated in tiny amounts. Some of these molecules eventually migrate across the surface until they reach cold traps near the poles. Once inside these shadowed regions, they freeze and accumulate over time. In this way, the moon may slowly gather ice deposits through natural processes operating over billions of years. The discovery of water transformed scientific understanding of the moon. For decades, the moon had been viewed as an extremely dry and hostile environment. The presence of water changed that perception dramatically. Water is one of the most valuable resources for space exploration. It can be purified for drinking, broken down into hydrogen and oxygen for breathing, and converted into rocket fuel. Because of these possibilities, the lunar poles have become a major focus for future exploration. Scientists believe that some polar craters may contain substantial deposits of ice hidden within the soil. These resources could support long-term human missions to the moon. Instead of transporting large quantities of water from Earth, future astronauts might be able to harvest ice directly from the lunar surface. Modern space programs are already planning missions aimed at studying these icy regions more closely. The Artemis program, led by NASA, aims to return humans to the moon in the coming years. One of the key objectives of this program is exploring the lunar South Pole, where many permanently shadowed craters are located. Scientists hope to measure how much ice exists in these areas and determine how accessible it may be for future explorers. Among the most intriguing locations is Shackleton Crater, a deep impact basin located almost exactly at the moon's south pole. Because sunlight barely reaches the interior of this crater, its floor remains in permanent darkness. Some researchers believe that thick deposits of ice may lie hidden beneath the surface there. If confirmed, these deposits could become a vital resource for sustained human presence on the moon. The discovery of water also provides new insights into the history of the solar system. Scientists continue debating how most of this water arrived on the moon. One possibility involves comet impacts during the early history of the solar system. Comets contain large quantities of frozen water and other volatile compounds. Repeated impacts over billions of years could have delivered ice to the lunar surface. Another possibility involves water-rich asteroids striking the moon. Certain types of asteroids contain hydrated minerals and frozen compounds. When these bodies collided with the moon, some of their water may have become trapped within cold polar regions. Over time, these impacts could gradually build up significant ice deposits. Whatever its origin, the presence of water has reshaped how scientists think about the moon's environment. What once appeared to be a completely dry and lifeless world now seems more complex than previously imagined. Hidden beneath layers of dust in the darkest craters, frozen water may preserve a record of ancient events stretching back billions of years. Even with these discoveries, many questions remain unanswered. Scientists still do not know exactly how much ice exists on the moon or how it is distributed across the polar regions. Future missions will continue investigating these deposits with improved instruments and landers capable of drilling into the lunar soil. These studies may reveal that the moon is not merely a relic of the past, but also a gateway to the future of space exploration. Yet another slow but remarkable process is unfolding within the Earth-Moon system. Although the moon appears fixed in our sky, it is slowly drifting away from Earth year after year. This gradual movement is almost imperceptible during a human lifetime. But over millions of years, it will reshape the future of both worlds. When astronauts traveled to the moon during the late 1960s and early 1970s, they were not only explorers, they were also setting up experiments designed to continue working long after they returned home. Among the most important of these experiments were small devices placed on the lunar surface known as laser retroreflectors. At first glance, they appear simple, consisting of arrays of precisely shaped mirrors mounted in protective frames. Yet these mirrors have enabled one of the most accurate measurements ever performed in planetary science. For more than 5 decades, scientists have used them to track the distance between Earth and the Moon with astonishing precision. The first of these retroreflectors was placed on the Moon during the mission of Apollo 11 in July 1969. Astronauts installed the device on the Sea of Tranquility shortly after their historic landing. Additional reflectors were deployed during later missions, including Apollo 14 and Apollo 15. Similar mirrors were also delivered to the lunar surface by robotic vehicles known as Lunar rovers, launched by the Soviet Union. Together, these devices created a network of reflectors that scientists could target from Earth. The experiment itself relies on an elegant physical principle. Powerful observatories on Earth fire short pulses of laser light toward the Moon. These pulses travel through space at the speed of light until they strike the retroreflectors on the lunar surface. The mirrors are designed so that incoming light is reflected directly back toward its source. When the light returns to Earth, sensitive detectors measure exactly how long the round trip required. Because the speed of light is known with extraordinary precision, scientists can calculate the distance traveled by the laser beam. The total time measured during the experiment corresponds to the journey from Earth to the Moon and back again. By dividing this distance in half, researchers determine the exact distance between the observatory and the lunar reflector. The accuracy of this method is remarkable. Modern lunar laser ranging experiments can measure the Earth-Moon distance with an accuracy of only a few millimeters. Observatories around the world participate in these measurements. Facilities such as the McDonald Observatory in Texas and the Observatoire de la Côte d'Azur in France regularly conduct lunar laser ranging experiments. Over time, these measurements have produced a continuous record of the Moon's orbit stretching back more than 50 years. When scientists analyzed this long-term data, they discovered something surprising about the relationship between Earth and its natural satellite. The Moon is not maintaining a constant distance from Earth. Instead, it is slowly drifting farther away. Measurements show that the Moon's orbit is expanding by roughly 3.8 centimeters each year. This motion is extremely slow on human timescales. Over the course of a single lifetime, the Moon moves only a few meters farther from Earth. Yet over millions of years, the cumulative effect becomes significant. To understand why this happens, scientists must examine the gravitational interaction between Earth and the Moon. The Moon's gravity exerts a powerful influence on Earth's oceans. As the Moon pulls on our planet, it causes water to bulge outward in 2 opposite directions. One bulge forms on the side of Earth facing the Moon, while another forms on the opposite side of the planet. These bulges are what we experience as ocean tides. However, Earth is rotating beneath these tidal bulges. Our planet spins once every 24 hours, while the Moon takes about 27 days to complete one orbit. Because of this difference in motion, the tidal bulges do not remain perfectly aligned with the Moon. Instead, Earth's rotation drags the bulges slightly ahead of the Moon's position in orbit. This small offset has important consequences. The tidal bulges contain large amounts of mass and therefore exert their own gravitational pull. Because the bulges are positioned slightly ahead of the Moon, their gravitational attraction pulls the Moon forward along its orbital path. This extra pull increases the Moon's orbital energy, causing it to move into a slightly higher orbit around Earth. In effect, energy is being transferred from Earth's rotation into the Moon's orbit. As the Moon gains orbital energy, it moves farther away. At the same time, Earth loses a tiny amount of rotational energy. This causes our planet's rotation to slow down gradually over time. In other words, the length of Earth's day is slowly increasing. This process has been occurring for billions of years. Geological evidence preserved in ancient rocks confirms that the Earth-Moon system once behaved very differently. Certain sedimentary rock formations, known as tidal rhythmites, record patterns created by ancient tides. These layers form as sediments accumulate in coastal environments influenced by tidal cycles. By studying the spacing between these layers, scientists can estimate how often tides occurred in the distant past. Some of these tidal rhythmites date back hundreds of millions of years. When researchers analyzed them, they found evidence that Earth's days were once significantly shorter. For example, rocks from the Devonian period roughly 400 million years ago suggest that a year contained about 400 days. This means each day lasted only about 22 hours. The difference reflects the gradual slowing of Earth's rotation caused by tidal interactions with the Moon. If we travel even farther back in time, the differences become more dramatic. Shortly after the Moon formed about 4.5 billion years ago, it likely orbited much closer to Earth than it does today. Some models suggest the Moon may have been only 20,000 to 30,000 kilometers away. That distance is extremely close compared with the modern average of about 384,400 kilometers. At such a close distance, the Moon would have appeared enormous in the sky. Its gravitational influence on Earth would also have been much stronger. Ocean tides during this early period may have been hundreds of times more powerful than modern tides. Massive tidal surges would have swept across coastal regions, dramatically reshaping Earth's early landscapes. Some scientists believe these intense tides may have influenced the emergence of life on Earth. Tidal forces can create networks of shallow pools along coastlines. In these environments, water repeatedly flows in and out as tides rise and fall. This cycling can concentrate organic molecules that might otherwise remain diluted in the open ocean. Over long periods of time, such environments may have helped promote chemical reactions leading to the first biological systems. Although this idea remains an active area of research, it highlights how deeply the Moon's gravitational influence has shaped Earth's history. The slow transfer of energy between Earth and the Moon continues today, gradually increasing the length of Earth's day. The change is extremely small, amounting to only about 2 milliseconds per century. Yet over geological timescales, this gradual slowdown becomes significant. The Moon's outward drift will continue for billions of years into the future. As it moves farther away, its gravitational influence on Earth will slowly weaken. Tides will become slightly smaller, and the Moon will appear gradually smaller in the sky. One of the most noticeable consequences will involve solar eclipses. Today, the Moon and the Sun appear almost the same size in Earth's sky. This remarkable coincidence allows the Moon to completely cover the Sun during total solar eclipses. However, because the Moon is slowly receding from Earth, its apparent size is gradually shrinking. Millions of years from now, the Moon will appear too small to fully block the Sun. At that point, total solar eclipses will disappear, leaving only partial or annular eclipses. Even though this process unfolds extremely slowly, it reveals something profound about the Earth-Moon system. The relationship between these two worlds is not static. Instead, it is part of an ongoing gravitational dance that continues to evolve over time. The Moon influences Earth's oceans, our planet's rotation, and even the stability of Earth's axis. For most people, the Moon feels like a permanent companion in the night sky. It rises and sets with comforting regularity, guiding tides and marking the passage of time. Yet the measurements from lunar laser ranging experiments reveal a quieter truth. The Moon is gradually slipping farther away, centimeter by centimeter, year after year. This slow separation reminds scientists that planetary systems are constantly changing. Even relationships that appear stable over human lifetimes are evolving on cosmic timescales. Earth and the Moon have been locked together for billions of years, influencing each other through gravity in subtle and powerful ways. Understanding this relationship raises an even deeper question. If the moon has shaped Earth's tides, slowed our planet's rotation, and stabilized its orbital behavior, then how essential is the moon to Earth itself? The answer may reveal that our planet's long-term stability depends more on the moon than we once imagined. For most of human history, the moon was simply seen as Earth's companion in the night sky. It illuminated dark landscapes, guided ancient calendars, and controlled the rhythm of ocean tides. Yet modern astronomy has revealed that the moon may play a much deeper role in shaping the stability of our planet. Scientists now believe that without the moon, Earth itself might be a dramatically different world. The presence of this large natural satellite influences the motion, climate, and long-term stability of our planet in ways that were not fully understood until recent decades. To explore this idea, astronomers often begin with a simple question: what would Earth be like if the moon did not exist at all? At first glance, the answer might seem straightforward. Without the moon, nights would be darker and ocean tides would be weaker. Yet when scientists began examining this scenario using computer simulations, they discovered that the consequences might be far more profound. Removing the moon from Earth's system would alter the planet's rotational behavior and long-term climate stability. One of the most important roles played by the moon involves Earth's axial tilt, a property also known as obliquity. Earth is tilted about 23.5 degrees relative to the plane of its orbit around the Sun. This tilt is responsible for the seasonal cycles that shape climates across the planet. When the northern hemisphere tilts toward the Sun, it experiences summer, while the southern hemisphere experiences winter. 6 months later, the situation reverses. The changing angle of sunlight across the year creates the predictable seasonal patterns that ecosystems and agricultural systems depend on. Earth's axial tilt might seem permanent, but in reality, it is influenced by gravitational forces acting on the planet. The Sun exerts a powerful gravitational pull on Earth, and the gravitational influence of other planets also affects Earth's motion over long timescales. These interactions can cause the orientation of a planet's rotation axis to shift gradually through a process known as axial precession. Over tens of thousands of years, Earth's axis slowly traces a circular motion in space, similar to the wobble of a spinning top. The moon plays a crucial role in stabilizing this motion. Because the moon is relatively large compared with Earth, its gravitational pull acts as a stabilizing anchor for Earth's rotation axis. The moon's gravity helps prevent large swings in Earth's tilt by damping the chaotic effects produced by interactions with other planets. In essence, the moon helps keep Earth's axial tilt within a relatively narrow range over long periods of time. Astronomers first began studying this stabilizing effect in detail during the late 20th century. One of the most influential studies was conducted by French astronomer Jacques Lascar during the 1990s. Using powerful computer simulations, Lascar explored how Earth's axial tilt might behave if the moon were removed from the system. The results were striking. Without the moon's stabilizing influence, Earth's tilt could vary dramatically over millions of years. Some simulations suggested that Earth's obliquity might fluctuate between nearly 0 degrees and as much as 60 degrees. Such extreme changes would transform Earth's climate. When the tilt approached 0 degrees, seasonal differences would nearly disappear. Regions near the equator would receive consistent sunlight year-round, while the poles would remain permanently cold. At the other extreme, a tilt of 60 degrees would produce incredibly intense seasonal variations. In that scenario, one of Earth's poles could point almost directly toward the Sun during part of the year. Polar regions that are currently covered in ice might experience periods of intense sunlight and heat. Meanwhile, other parts of the planet could spend months in darkness. These dramatic climate shifts could occur repeatedly over geological timescales, creating a far less stable environment for life. The moon's gravitational presence helps prevent these chaotic variations. By stabilizing Earth's rotation axis, the moon helps maintain the moderate tilt that produces relatively predictable seasons. This stability may have been crucial for the long-term development of complex life on Earth. Over hundreds of millions of years, stable climate patterns allowed ecosystems to adapt and evolve within consistent environmental conditions. The Moon also exerts a powerful influence on Earth's oceans. Its gravitational pull generates the tides that rise and fall along coastlines across the world. While the Sun also contributes to tides, the Moon is responsible for the majority of tidal forces on Earth. As Earth rotates beneath the Moon's gravitational field, tidal bulges move across the planet's oceans. These tides influence coastal ecosystems, sediment transport, and ocean circulation patterns. Ocean tides may have played a particularly important role during the early history of life on Earth. Billions of years ago, the Moon orbited much closer to Earth than it does today. Because tidal forces increased dramatically with decreasing distance, the early Moon would have generated extremely powerful tides. These tides may have created vast networks of shallow tidal pools along ancient coastlines. Some scientists propose that these environments could have helped concentrate organic molecules in ways that promoted the chemical reactions leading to life. As tides repeatedly filled and drained shallow pools, molecules dissolved in seawater could become increasingly concentrated. This process may have created conditions favorable for the formation of complex organic compounds and early biological structures. Although this idea remains an active area of research, it highlights how the Moon's gravitational influence may have shaped the environment in which life emerged. Even today, tides continue to influence ecosystems in coastal regions. Many marine organisms rely on tidal cycles for feeding, reproduction, and migration. In this sense, the Moon remains an important factor in Earth's biological rhythms. The Moon also affects Earth's rotation. As described in the previous chapter, tidal interactions gradually slow Earth's rotation over time. Energy from Earth's spinning motion is transferred into the Moon's orbit, causing the Moon to move slowly farther away. As a result, the length of Earth's day increases very gradually over millions of years. Geological evidence suggests that hundreds of millions of years ago, Earth rotated significantly faster than it does today. For example, fossil coral growth rings reveal that around 400 million years ago, Earth experienced approximately 400 days per year. This means each day lasted just under 22 hours. Over time, tidal friction has gradually slowed Earth's rotation to the 24-hour day we experience today. Without the Moon, this rotational evolution might have followed a different path. Astronomers studying other planetary systems have begun considering whether large moons might influence the habitability of distant worlds. Thousands of planets have now been discovered orbiting other stars, many of them potentially rocky worlds similar to Earth. Scientists refer to these distant planets as exoplanets. One question researchers now ask is whether such planets might also possess large moons capable of stabilizing their axial tilt. Detecting moons around distant planets remains extremely challenging. These objects, known as exomoons, are far smaller than the planets they orbit and are difficult to observe directly. However, astronomers are developing new methods to search for subtle signals that might reveal the presence of such moons. If large moons prove to be common around habitable planets, they could play an important role in creating stable environments for life. Earth's moon may therefore represent an unusually fortunate feature of our planetary system. Its presence contributes to a stable climate, predictable seasons, and the long-term evolution of Earth's environment. While the Moon is not the only factor that makes Earth habitable, it appears to be an important component of the system that supports life on our planet. If the Moon had never formed, Earth might still host life, but the planet's climate could be far less stable. Large variations in axial tilt could produce extreme environmental changes over geological timescales. Ocean tides would be weaker, potentially altering marine ecosystems and coastal environments. Even Earth's rotation might behave differently without the long-term influence of lunar tidal forces. These possibilities highlight how interconnected the Earth-Moon system truly is. The Moon is not simply a passive object orbiting our planet. It is an active participant in the dynamics of Earth's environment. Through gravity alone, the Moon influences our planet's oceans, rotation, and climate stability in subtle but powerful ways. For most people, the Moon appears as a quiet presence in the night sky. Yet its gravitational influence has shaped Earth's history for billions of years. Without the Moon, the story of our planet might have unfolded very differently. Today, humanity stands on the edge of a new era of lunar exploration. After decades of relative silence following the Apollo missions, scientists and space agencies are preparing to return to the Moon. These new missions aim not only to explore its surface, but also to establish a sustained human presence there. The next chapter examines this renewed push toward the Moon and the ambitious missions that may soon carry humans back to its surface once again. More than half a century has passed since humans last walked on the Moon. In December 1972, the astronauts of Apollo 17 climbed back into their lunar module and left the surface behind. Their departure marked the end of one of the most extraordinary periods of exploration in human history. For the next several decades, no human would travel beyond low Earth orbit. Space agencies shifted their attention toward new priorities, including reusable spacecraft and long-term space stations. The Moon, once the focus of intense exploration, became a quieter frontier waiting for humanity's return. During the decades following the Apollo program, space exploration did not stop. Robotic spacecraft continued to visit the Moon and collect valuable scientific data, yet human missions remained focused closer to Earth. Programs such as the Space Shuttle and the construction of the International Space Station allowed astronauts to conduct experiments in orbit and develop technologies for long-duration spaceflight. These missions expanded humanity's knowledge of living and working in space, but the dream of returning to the lunar surface remained unfulfilled for many years. In the early 21st century, interest in the Moon began growing once again. Scientists and policymakers realized that the Moon offers unique opportunities for both research and exploration. Unlike distant planets, the Moon lies only about 3 days away from Earth. This relatively short travel time makes it an ideal location for testing technologies needed for deeper space missions. At the same time, new discoveries about the Moon's resources have transformed how scientists think about its potential role in the future of space exploration. In 2017, NASA formally announced a new initiative known as the Artemis program. Named after the twin sister of Apollo in Greek mythology, Artemis represents the next chapter in humanity's relationship with the Moon. While the Apollo missions demonstrated that humans could reach the lunar surface, Artemis aims to establish a sustainable presence there. Instead of brief visits lasting only a few days, future missions may support astronauts living and working on the Moon for extended periods. One of the most important goals of the Artemis program is returning astronauts to the lunar surface for the first time since the early 1970s. These missions will focus on a region that has never been explored by humans before, the Moon's south polar region. This area lies near the boundary between sunlight and permanent darkness. Because of the Moon's small axial tilt, some craters near the poles never receive direct sunlight. These permanently shadowed craters remain extremely cold and may contain significant deposits of frozen water. The presence of water ice at the lunar poles has transformed how scientists think about future exploration. Water is one of the most valuable resources for space missions. It can be purified for drinking, split into hydrogen and oxygen for breathing, and converted into rocket fuel. If lunar ice can be extracted efficiently, it could support long-term human missions and reduce the need to transport supplies from Earth. This possibility has made the lunar South Pole a major focus of modern exploration plans. To support these missions, NASA is developing several new spacecraft and technologies. One of the most powerful rockets ever built is the Space Launch System. commonly known as SLS. This massive rocket is designed to carry astronauts beyond Earth orbit and send them toward the Moon. At the top of the rocket sits the Orion spacecraft, a crew vehicle built to transport astronauts safely through deep space and back to Earth. The first major test of this system occurred in November 2022 with the launch of Artemis 1. This uncrewed mission sent the Orion spacecraft on a journey around the Moon before returning safely to Earth. The mission lasted more than 3 weeks and tested many of the systems that will be used during future crewed flights. Engineers closely analyzed the data returned by Orion to ensure the spacecraft could safely carry astronauts on upcoming missions. Future Artemis missions will build upon this foundation. The mission known as Artemis 2 is planned to send astronauts on a crewed journey around the Moon without landing. This flight will test life support systems and deep space navigation with a human crew aboard Orion. If successful, the following mission, Artemis 3, aims to land astronauts on the Moon's surface near the South Pole. This mission is expected to include the first woman and the first person of color to walk on the Moon, expanding the legacy of human exploration. Another key element of the Artemis program is the development of a small lunar space station known as the Lunar Gateway. This station will orbit the Moon and serve as a staging point for lunar surface missions. Astronauts traveling from Earth will dock with Gateway before descending to the lunar surface in specialized landing vehicles. The station will also support scientific research and provide a platform for testing technologies needed for future missions deeper into the solar system. Unlike the Apollo era, modern lunar exploration is becoming increasingly international. Multiple countries and space agencies are developing their own missions to the Moon. The European Space Agency, the Japan Aerospace Exploration Agency, and other international partners are collaborating with NASA on aspects of the Artemis program. These partnerships reflect a growing recognition that exploring the Moon is a global endeavor requiring shared expertise and resources. Other nations are also pursuing independent lunar programs. China's ambitious lunar exploration effort, known as the Chang'e program, has achieved several major milestones in recent years. In 2019, the Chang'e 4 mission successfully landed on the far side of the Moon, marking the first time any spacecraft had accomplished this feat. China has since continued developing plans for future robotic missions and potential human landings. China and Russia have also proposed constructing a joint research facility near the lunar South Pole, known as the International Lunar Research Station. This concept envisions a network of robotic landers and eventually human missions working together to study the lunar environment. Such plans highlight the growing competition and cooperation shaping the new era of lunar exploration. Private companies are also playing an increasingly important role. In recent years, commercial aerospace firms have begun developing spacecraft capable of transporting cargo and astronauts to the Moon. One of the most notable examples is SpaceX, which is building the large reusable spacecraft known as Starship. NASA has selected Starship as the human landing system for future Artemis missions. If successful, this vehicle could carry astronauts from lunar orbit down to the surface and back again. Another company, Blue Origin, is also developing lunar landing technology through its Blue Moon program. These efforts represent a major shift in how space exploration is conducted. Instead of relying solely on government agencies, modern lunar missions increasingly involve partnerships with private industry. The Moon is also attracting attention because of its potential resources. Lunar rocks contain valuable materials such as titanium, aluminum, and oxygen bound within minerals. These elements could eventually be extracted and used to build infrastructure directly on the Moon. Constructing habitats, vehicles, and equipment from local materials would reduce the need to launch heavy supplies from Earth. Another resource that has sparked scientific interest is helium-3, a rare isotope of helium embedded in lunar soil. Some researchers believe helium-3 could potentially be used in future nuclear fusion reactors. Fusion energy remains an experimental technology, and using helium-3 as a fuel source would require major breakthroughs in physics and engineering. Nevertheless, the presence of this isotope has generated discussion about the long-term economic potential of lunar resources. Beyond resources and exploration, the Moon may also serve as a stepping stone for missions deeper into the solar system. Establishing a permanent human presence on the Moon would allow astronauts to test life support systems, habitats, and transportation technologies needed for future journeys to Mars. The Moon's weaker gravity makes launching spacecraft easier than launching directly from Earth. This could allow future missions to assemble and fuel spacecraft in lunar orbit before traveling to more distant destinations. As humanity prepares to return to the Moon, the goals of exploration are evolving. The Apollo missions demonstrated the remarkable achievement of reaching another world. The Artemis program and other international efforts aim to transform the Moon into a place where humans can live, work, and conduct research over extended periods. Instead of short visits, future explorers may build laboratories, habitats, and infrastructure that support ongoing scientific discovery. In this sense, the Moon may soon become more than a distant object in the night sky. It could become the first permanent outpost of human civilization beyond Earth. Yet even as new missions prepare to return humans to the Moon, many mysteries remain. Despite centuries of observation and decades of exploration, scientists continue uncovering surprising details about our closest celestial neighbor. Each discovery raises new questions about the Moon's origin, structure, and long history in the solar system. As this documentary approaches its conclusion, the final chapter reflects on those remaining mysteries and what the Moon may still reveal in the future. After thousands of years of observation and decades of scientific exploration, the Moon remains one of the most familiar objects in our sky. Ancient civilizations watched its phases and tracked its motion long before telescopes existed. Early astronomers mapped its craters and mountains using primitive instruments. In the 20th century, robotic probes and human explorers finally reached its surface. Yet even after all of these discoveries, the Moon still holds many unanswered questions. Each new mission has revealed remarkable insights, but the closer scientists look, the more mysteries seem to appear. One of the most important unanswered questions involves the Moon's origin. Today, most planetary scientists support the giant impact theory, which proposes that the Moon formed after a colossal collision between the young Earth and a Mars-sized protoplanet known as Theia. According to this model, the impact ejected enormous quantities of molten rock into orbit around Earth. Over time, this debris gradually coalesced into the Moon. Computer simulations reproduce many features of the Earth-Moon system using this scenario. However, certain details remain difficult to explain. For example, lunar rocks collected during the Apollo missions show an almost identical chemical composition to rocks found in Earth's mantle. If the Moon formed primarily from debris originating from Theia, scientists might expect to see stronger chemical differences. Instead, many isotopic signatures appear nearly indistinguishable between Earth and lunar samples. Researchers continue investigating whether the collision thoroughly mixed the materials of both bodies or whether most of the debris actually originated from Earth itself. Determining the precise contributions from Earth and Theia remains one of the most challenging puzzles in planetary science. Another mystery involves the dramatic differences between the two hemispheres of the Moon. Anyone who looks up at the Moon from Earth sees the familiar pattern of dark plains, known as Lunar Maria, scattered across its near side. These plains formed billions of years ago when volcanic lava flooded enormous impact basins. Yet the far side of the Moon looks completely different. Instead of smooth volcanic plains, it is dominated by rugged highlands and densely packed craters. Scientists have proposed several explanations for this asymmetry. One idea suggests that the Moon's crust is significantly thicker on the far side than on the near side. This thicker crust may have prevented magma from reaching the surface, limiting volcanic activity in those regions. Another theory proposes that the early Earth heated the hemisphere of the Moon facing our planet. Because the young Earth radiated intense heat after the giant impact, the near side of the Moon may have cooled more slowly, influencing the formation of its crust. Despite these possibilities, researchers still lack a complete explanation for why the two hemispheres evolved so differently. The Moon's internal structure also remains an active area of research. Seismic experiments conducted during the Apollo era revealed that the Moon possesses a layered interior consisting of crust, mantle, and a small core. However, the exact properties of these layers remain uncertain. Scientists believe the lunar core may contain a partially molten region surrounded by a solid inner core. Determining the precise size and composition of this core requires more detailed seismic measurements than those available from the Apollo instruments. Future missions may deploy new networks of seismometers across the lunar surface. These instruments could measure moonquakes with far greater sensitivity than earlier experiments. By analyzing how seismic waves travel through the Moon, scientists hope to construct more detailed models of its interior. Such information would help explain how the Moon cooled over billions of years and why its geological activity eventually declined. Another location that holds great scientific promise is the enormous South Pole Aitken Basin. This basin is one of the largest and oldest impact structures in the entire solar system. It stretches roughly 2,500 kilometers across the Moon's far side and was created by a colossal asteroid impact billions of years ago. The energy released during that collision was so powerful that it likely excavated material from deep within the Moon's mantle. Studying rocks from this basin could provide direct evidence about the composition of the Moon's interior. Unfortunately, most of the basin lies on the far side of the Moon, making exploration difficult. Robotic missions have begun studying this region, but scientists hope that future sample return missions will collect rocks directly from the basin. These samples could reveal important clues about the Moon's formation and early geological history. The discovery of water ice near the lunar poles has also raised new questions. Missions such as El-Cross and Chandrayaan one confirmed that water exists within permanently shadowed craters. Yet scientists still do not know exactly how much water is present or how it arrived on the Moon. One possibility involves comet impacts delivering ice to the lunar surface. Another explanation suggests that hydrogen from the solar wind interacts with oxygen in lunar minerals to form water molecules. Determining which process contributed most to the Moon's water remains an important goal for future missions. The Moon also holds clues about an ancient period known as the Late Heavy Bombardment. Around 3.8 to 4.1 billion years ago, the inner solar system experienced an intense spike in asteroid impacts. Evidence of this violent era is preserved in the Moon's cratered landscape. Unlike Earth, where plate tectonics and erosion have erased most ancient impact scars, the Moon's surface preserves a record of these collisions. By studying lunar craters and rock samples, scientists can reconstruct the early history of the solar system and learn more about the environment in which Earth formed. Another intriguing puzzle involves the Moon's ancient magnetic field. Today, the Moon has no global magnetic field like Earth's. However, certain lunar rocks show signs of magnetization that must have occurred billions of years ago. This suggests the Moon once possessed a magnetic field strong enough to magnetize surface rocks. Researchers are still trying to determine how such a small body could have generated a field of this strength. Some theories propose that the Moon's molten core once produced a magnetic dynamo similar to Earth's, while others suggest that large asteroid impacts may have temporarily generated magnetic fields through shock processes. Future exploration will play a crucial role in answering these questions. Programs, such as Artemis program, aim to return astronauts to the Moon and establish a long-term presence there. New missions will carry advanced scientific instruments capable of analyzing the moon's geology in unprecedented detail. Astronauts may collect rock samples from regions that have never been explored before, including areas near the lunar South Pole. Robotic spacecraft will also continue playing an important role. Landers, orbiters, and rovers can operate in environments that remain difficult for humans to reach. These missions may deploy new seismic networks, drill into polar ice deposits, and map underground structures using radar instruments. Each mission will add another piece to the puzzle of the moon's complex history. The moon may also become humanity's first permanent outpost beyond Earth. Resources such as water ice, oxygen bound in lunar minerals, and metals found in lunar rocks could support future exploration. If these materials can be extracted efficiently, they may allow astronauts to build infrastructure directly on the moon. Over time, the moon could become a staging point for missions to Mars and other destinations deeper in the solar system. Despite all these technological advances, the moon continues to inspire curiosity and wonder. It has guided human cultures for thousands of years, shaping myths, calendars, and scientific discoveries. From ancient sky watchers to modern astronauts, the moon has remained a constant presence in humanity's exploration of the cosmos. Yet the moon is far more than a simple companion to Earth. It is a world shaped by colossal impacts, volcanic eruptions, and billions of years of cosmic history. Each crater and rock formation tells part of a story that stretches back to the earliest days of the solar system. And even after centuries of study, that story is still unfolding. When the moon rises above Earth's horizon, it appears calm and familiar. But beneath its quiet surface lies a record of planetary violence, geological transformation, and cosmic evolution. The more scientists learn about the moon, the more they realize how much remains unknown. The moon may be the closest world to Earth, yet it still holds secrets waiting to be discovered.